Hey. Here we go. This is time. Hopefully we can finish the save system this time. Yeah, we can finish the save system this time, hopefully. Yeah, we can finish the Oh wait, it's still... Okay. Let's stop playing this. Okay. Here we go. I'm a bit tired. My apologies. Ah. Oh. Let me just put this. And we'll get started pretty soon. Okay. And now, here we go. Perfect. So, hello people, it's Prugs, and today we're listening to some BGM from Adas. Very nice BGM. I hope the volume is fine. And we have our character. We actually didn't do anything last time, right? We still have, we can still place blocks, we can still break blocks. We can place like a tower and copy all of this, for example. Right? Like this. Which is pretty nice. But now we actually want to save all of this. We want to save it onto a file, for example. Yeah. We want to save it. Sounds good to me. So, yeah, basically the code isn't actually compiling. I'm just playing my game, but the code isn't actually compiling. Because of some problems with the buffer, I think. Buffer ref, right? I have to get this, for example. Get this. Now I have to do point get. And same here, probably. I noticed that just before starting. So let's actually just do this point get. Yeah, actually it's going to be better like that. I'm just gonna do that. Because I added this, right? I have a reference wrapper around my buffer. So I just do those. What the fuck? What is this font? I mean, that's original. I don't really want to ban you because it's a bit original. It's the first time I see this font for some bad promotion. But I guess I have to, right? It's like in the Code of Honor. I have to do that. Hey, what's up? Hey, Bigakos. Hey, how are you? Are you still here? Or was it from last time? Oh. Hello. So this is normal. Let's run. Yeah, it's the first time I really listened to the BGM from Adas. It's not bad. It's nice. I like it. Okay. Message Pack is not a member of Voxel. What the fuck? Where's that? Okay, it's there. The declaration. So this is the declaration, and where am I using this? Pack, I guess. No. Wait, what? With P equals voxel map value. Wait, this is voxel map value. Oh, right. Yeah, it is. Right, so yeah, we need the name. So you have like the value, maybe. And we have the voxel name. Hey, people! Let me just actually change the description for my stream. This time it's 8. Here we go. So now it should work, I guess. Maybe it's gonna work, maybe it's not gonna work. We're gonna see. But I also want to... Well, I'm doing some serialization, right? But I also want to test it. I want to test it, and I'm not sure it works. I forgot if it was working or not. I mean, this is working, I believe. But that's it, right? That's all I know. Deserialize. Yeah, I mean, okay, this is working. Well, should be good then. Maybe. So this is not a member of string name. Where is it this time? It's there still? Wait. So what? MSG pack is not a member of string name. What do you mean? The declaration. So do I need to convert it into something that is supported? I suppose, right? Like if I go there, it's T. And it has to be valid somehow. This points back. Oh yeah, so for most objects it's supposed to be this points back. So is there like a string version? So let's do pack object. Zone. Wait. As convert T operator equal. Yeah, I don't think I actually have. So pack with T, and that's basically it. Is it? I mean, there should be some specializations, but I guess not really. So let me just try this again. Message pack. Serialize string name. I mean, I guess it's gonna be a string. Guess property name. True. What? Oh, I want this in C++. Go to C++. Wait, they're talking about this in Godot. It doesn't. Binary serialization. So on non-Godot servers for implementing the Godot packet format. Well, it doesn't seem to be. I'm not sure about that. Well, okay. Yeah, I guess it was previously. It was all this on the previous repository. That's why it's not finding. Well, it's not. It's closed. So I need to do something. I need a pack function. Let me actually just GPT, because I think I can just write, for example, the length and then the size of the thing. But, well, no, well, first the length and then just write the string, right? But, or just put a \0. But yeah, Godot CPP message pack string name. So pack pack str. That's why I didn't find like a string specialization. It's because it's a specific function. Makes sense. Or if you're using adapter, make a specialization. Well, yeah, no. I mean, I could. So the length, and then the body. Got it? UTF-8. I mean, I guess this could be fine. Okay, so pack string. To pack string. Do you have the size? Well, this way. Wait, length? I guess length. So well, it's an int, it's not a uint, I don't know why, but yeah. So we have this. We put the size. And then we have the name. And we have the size. Right. Wait. PTR. Wait, what was it? Get data. Here we go. No, pack. Wait. Pack str content or pack str body. Right. Str body. From car 32. Oh, 32. Oh. Yeah, how can I convert that? I think it's like wait, let me check this. Yeah, car 32. Ew. Point UTF-8 is what it's proposing. But I don't actually have that, do I? So I'm not sure how expensive string names are. I mean, they're string names. It's not even a string. Why does it have support for like this? I mean, I'm gonna have to convert, I guess. Let me just search on Google this time. String name, Godot string name, UTF-8. UTF-8? No, it's not UTF-8. I just want the byte, right? Try from bytes. Oh. Yeah, let me just get the bytes. I mean, I guess I can just cast, technically. But, yeah. Exactly 8 bytes. No. That's not what I want. Immutable. Yep. So 2 UTF-8 buffer. What about in C++? Is it a function from the type, or is it... What? Why is it faster? Yeah. I don't have UTF-8. Do I have buffer get data? I mean, data is already a car 32. I have the... Never mind, I don't have an arrow. I have a string operator. Wait, it's supposed to convert? Oh, no, it just returns the string. Oh. Well, technically we can get the string. And wait, what does the string do? Like PTR, car 32. But let's have UTF-8. Right. This is it. But it's a static function. So 2 UTF-8 buffer is what I want, right? Something like this. And now I have to convert from fact byte array. Oh my god. Wait. Is it actually... Oh no. Wait, UTF-8? Wait, what's going on? S, UTF-8. Yeah, so I don't want to convert it to like a buffer, right? To another buffer. I just want to get this. What is that? Cow. So UTF-8. And that's it. Is it? L. Resize. Ew. Wait. It takes a vector. And it returns a string. I don't know about that. I don't know. Serialization for maths. Let me just try this. Should I save strings? What is it again? It's not about UTF-8. Wait. What is UTF-8? Get data. I mean, I guess... I don't know. I don't know if Godot has like some special things. Get data. Wow. UTF-8. Wait. String to card string. UTF-8, get data. This is more efficient than this because the data may go through this string handling and is less explicit about the length. Yeah, I mean, I know. Yeah, I mean, well, no, I know. Loading back. So point UTF-8. Why save in UTF-8? Okay. SH pack strings are defined as UTF-8 text. It distinguishes text and UTF-8 strings from binary. I could, but nah. So, I mean, I guess UTF-8, but I'm not sure about that, right? Because there's no UTF directly here, and he's telling me to do this. Do what actually? Don't use ASCII. I mean, I don't really care, right? Creates a temporary UTF-8 representation. since Godot string is internally UTF-32, rather than UTF-8, a conversion is generally unavoidable. So, what about storing UTF-32? Yeah. Because I mean message pack is supposed to use UTF-8 strings, I guess. As raw binary. Drawbacks. So what are the differences? I don't really need that, right? Yeah, it does matter for me. You want to avoid UTF-32, UTF-8 conversion? Yeah, UTF-8. So what am I losing? Emojis. No text information. After decoding, I get the same thing now. Direct memory copy. Wait, so if I... Wait. Fixed size characters. UTF-32 uses 4 bytes. UTF-8 uses 1 to 4. Yeah, no, let's use UTF-8. Well, yeah, UTF-8. UTF-8 is good. So we have this, and now we do the pointer. We get the pointer. And I guess we're just gonna have... name, maybe? Like this, maybe? Buffer. Car string. Like this. So it's gonna be the buffer. Buffer, name. Buffer. So then we have the size. Is it coding? It's getting the size. Let me use this directly. Name buffer size. Let me compute this one time. Well, it's not really necessary, really, but yeah. I have this here. I can remove this. And I can bring the buffer here. Boom. Okay, is it working now? Hopefully it does. Hopefully it is. Oh, my bad. Yeah, I was thinking I might not string for long tonight. I'm a bit tired. Ooh. Okay. Okay. Okay, so it's working. It's compiling finally. So now that it's compiling, I have all of this. But now I need to be able to load this, right? So how am I going to do that? I mean, first I guess I want some kind of function. Well, I want a deserialize function, and I want a unit test for that. So we have serialize with the buffer. And we need the deserialize somewhere. Mm-mm-mm. Yeah. Deserialize. So this is serialize. This is serialize for the array cube chunk thing. Am I actually using this? I'm not, right? I'm just using the get compressed voxels instead directly, which is fine. I think. Yeah, I guess it's a bit different. No, never mind. It's not the one. I'm using. Wait, what? What am I using? Bytes. Wait. Oh, it bytes. Right. Yeah, it's this. Okay, never mind. Yeah, I mean, okay, that's fine. That's fine. Let's keep this like this. So serialize, and let's just add a little test. So we have all of this. Padding. Oh, okay. Let's have another test. That's going to be cube chunk serialization. Well, I guess this one is voxel. Well, not voxel area actually. Well, voxel area is gonna be here. That's fine. Let's have that. Voxel area. So I do voxel. I do out of this. I set the ID. So I guess well, it's the same thing anyways, right? It's basically initialize dummy. Initialize dummy. Maybe. So I need voxels. Wow. I need maybe all of this. Let me copy this instead. And then I have the test and stuff. Yep. I still need to bite. Bite the dust. Boo. Oh, so many people all of a sudden. Surprising. Hello. Hello, hello. So we're gonna use initialize dummy. We need the storage though. And we need to return the map. So storage is gonna be this. Okay. Wait, what am I doing? Okay, like that. So now we have everything. And then we initialize dummy with the storage and the map, which is going to be voxel map. Boom, map there. What is this? NV voxel. Oh no. Well, I mean, I guess it's fine, right? Maybe. Maybe I can just have it as an input. Like, here. 50 times 50 times 50. Here we go. And then we have the same over here with just what matters. Just this. Now we just have the test and that's good. I'm just gonna have... I'm not sure. Yeah, what if I put this minus 1 plus 1? So the goal of this is... What is it? The goal is to modulo and not have any air inside, basically. Because the goal of our new saving system is to remove unneeded blocks, right? So we shouldn't have 0. So I guess I can actually have something like 0, 1, 2, 3, 4, 5. And this is like forbidden. I think. Right, yeah, that's fine. Okay, that's fine. Padding. Should I just add padding plus I? Maybe. I guess. Good to me. Probably. Wait, no, that's not good. It's not gonna be an integer, is it? It's gonna be a ban instead. So I think it was something like string int into int num. Oh, it's num, right? It's num int 32 or int something like this. Num. Let's just skip this. Well, what is num? Is a double. Nah. Okay, let's have this. That way the padding has a suffix, and that's good. Dirty clanker! Be gone! Be gone! Disappear to the how is it? What's the name? To the shadow realm! Thanks for the hello. Do you want to see the game, or are you more interested in the code? If you have any question or anything, you know, go ahead. I'm gonna surprise you, but I'm here. I can read also. I can't talk very well, as you can maybe hear. I have this baguette accent. Just here to watch, okay. Good enough. So right now we are basically making the save system for the game. Let me just run this. You know, it's like a Minecraft game, right? Kind of. Except we have a donut, but we have blocks still. And the goal is to save structures. So I can basically do something like this, copy, paste, right? And I want to save my selection. To reuse it for generation, for example. Forward generation. So I'm trying to make unit tests because I do have my save function that should be working now. But I also want to make my load function, right? I want to load my voxels. And for that I'm making my unit test that is just checking if this is loading correctly or not. Well, I mean, that's gonna be the goal, right? The goal is gonna be to verify all of this. Storage to string. Well. Oh, it was there. Yeah, I mean, could be pretty simple. Maybe. If I do save, do I have? No, I don't have a save. Let me go to chunk save load. Struct. Okay, it's a struct. So, which one is the right one again? It's this one, right? Yeah, I don't have a load. Serialize. Oh, right, it's into a file. Yeah, I mean, I guess I'm just gonna serialize them. Right. So this is gonna be voxel area serializer because we want to test the serialization of the voxel area. And what do we need? Well, an area surprise. Oh, that's gonna be bad, is it? Local vector. Yeah, why do I still have this suggestion? It's supposed to be private, isn't it? It is. So voxel area. Maybe we are gonna have to include, I don't know. Yeah, probably. Actually, incomplete type, yeah. What is it? Modules, voxel core, area. Got it. Here we go. Boom. Now we can instantiate it. It's there. So we can bring it here. We also have the output, which is going to be a local vector. Local vector uint8. So buffer. Here we go, like bytes maybe. Bytes is good. And now it's gonna be good. Well, it's gonna be good. It's gonna, well, it's not actually. That's going to here because we have to initialize all of this. We have the space, we have the minimum, and we have the maximum. Ah. So the problem is with this. That means I'm gonna have to create my chunk. Well, I'm gonna have to create my space, create my chunk, and all of that. So we don't want to generate things though. So we're just gonna have like minimum equal vector3i 111, for example. This one is gonna be 35, 35, 35. The max. And then space equal well, it's gonna be a new, like mem new. So I guess I have to remove it at the end. I have to deallocate it. Mem new cube, well, cube space, cube chunk space. I don't have it here, so I'm gonna include it. Modules, core, spaces, this one. Actually, technically it should be about cube tourist chunk space probably, but let's say that's fine, maybe. I want it to work with this type, right? So let's do that. So we have the space. Oh, if I, well, okay, let's create the space before that maybe. Because we need the type. We need the type information that we are losing if we are assigning directly. So like this, and I want to, well, I want to set up the space before, right? I want to add a few chunks, for example. Add chunk. Oh, wait. Okay, something bad is. This is the first time I'm creating a chunk out of nowhere, like without the generation, like this. Well, since a while. It's been a while since I last did that. I guess I did that at the beginning, right, when I didn't have the generation, but yeah. And I'm saying it's kind of, I mean, it's good that I'm doing that now, because the goal is to use those spaces for a bunch of stuff. For example, for entities, potentially, right? So I do want to spawn multiple spaces, and if I can spawn a new space easily, then it's just good. I don't need the visual or the collision or anything. Yeah, I have this here. That's not good. That's fine. So add chunk. Well, I mean, let's just go into the generation maybe. I can just go into the generation module, and I should be able to see how I'm registering a chunk, how I'm adding a new chunk to all of this. Biomes? No. Chunk generator? No. This one? I feel like this music might be copyrighted. Maybe not. Okay. So wait, cube update, generate chunk. Oh, here we go. Generate. So we have all of this. And oh, I guess I'm just returning this. I mean, technically I could just generate actually. But yeah, let's just do that still. So we get the new chunk, on chunk loaded. We register the chunk. And then we try to update the neighbors. Oh, we do? I guess we do. But I guess that's fine too. So add chunk or register chunk? Oh. Let's go there. Do I have add chunk here? I don't. Add chunk, what is that? Oh, it's just a pushback. So I guess I need both. Register. Chunks pushback, never mind. Never mind. Wait, does that mean I'm adding this multiple times? Well, okay, never mind. So, it's valid coordinate, add child, everything's good. Can I create a tree? Well, that's fine. So, set as neighbors. Well, it won't be able to find the neighbors. So, okay, we have all of this. So now we need a chunk. Keep chunk. Do I want to set the size of this? For example, I have the amount of blocks. I have the block size, I have the amount of cubes, I have the default chunk size. I could set this. I wanna set some values to test if it's working well. So this is gonna be something like, I don't know this. Oh, actually it needs to be bigger than that. Let's have something that's not equal. So we're gonna have 63, 24, and 15 maybe? Actually 63 is like pretty big. 41, yeah, it should be good. It's less than my actual chunks. Than my in-game chunks. So I mean, the goal is just to unit test, right? We don't need like all of this to unit test. We don't need a bunch of data. So I mean, well, I could just do something like this actually. Now we have like 5 or 4 maybe. Well, no. Well, 15, 9, 10, 11, and 15, 16, 17. Good. So now, set NB cubes. Wait. Right, that's the chunk size. Well, I mean, technically I can set the amount of cubes. Set NB cubes. That's gonna be alright. I can have a bit more. I mean, I don't really care about this because in the end I'm actually only going to have like one chunk. What else can I have? Cubes, size, default size, block size. I mean, I think that's it. I actually don't have a lot of data. That's good. I thought I had more data in my space. I was worried about the size, the memory size. Well, I do kind of. Well, it's a lot of pointers. That's fine. Well, yeah. So we create a new chunk and we register it. I need to add chunk. Wait. Oh, right. Chunk. Can I go in? What do I have? Storage and the coordinates. So I have to set this. I have to set this, and then we have the amount of blocks. I guess I have to set this too. Wait, NB blocks. Yeah, how am I setting this actually? Like, let's check the references. Like, find all references. I mean, it's protected, right? So is it set NB blocks? Oof. not generated. I mean, I guess I can have that. Or maybe not. Generate chunk. Oh, it's there. Wait, I can actually generate the chunk. Chunk generate. Wait. Wait. Oh, well, it's the default. Yeah, okay, no, I'm not using this anymore. Yeah, I should remove this, really. Yeah, that's like very old. Isn't it? I mean, this is kind of old too. But it's supposed to be more optimized, right? That's fine, I don't really care. Well, I kind of do actually. Because it's gonna be pretty important, I feel like. Okay. So we can remove this, maybe. Can we? Yeah. Let me check the references. Find all references. It does have one, at least. Generate. I removed it. Then we have this and we have this. So generate all chunks. This one is not valid anymore. Well, this function is not... Yeah, it's not there anymore. So I can also remove it. Generate all chunks. I mean... Yeah, I don't have the generator, right? It's like another class now. Let's remove what we are not using. Like this. I was binding this 2 times. Wait. Oh, this one is for the cube chunk generator. So this one is actually... It actually should be working. Okay, good. So what about the reference for this one? I'm not using that, am I? Let me remove this. Cleaning a few things. One at a time. And we have this one. Find references. Yeah, that's what I thought. It's not actually being used. So removed. Removed. I don't want things to get ambiguous. Why is it here? That's fine. But now, what do I do? What do I do now? Register chunk, let me... Well, I should just... Yeah, just the references, but yeah. Uncheck clouded, so we register the chunk. And then we try to update. Or we don't. So that's good. What about when I generate? So generate cube chunk, we have all of this, we have the resize uninitialized. Well, and we have a bunch of stuff. Well, I guess I don't actually have a lot of things here. Do I? Yeah, the only thing is that this should be like created before, from what I understand. Chunk loader. Maybe somewhere around here. I don't remember the name. I think it was in the visual loader. We have all of this. And that's it. I don't remember where it was. But you know what? That's fine. I can just go here. I can just do chunk cards. Maybe. And yeah, how am I setting the size? Like, where am I setting the size? Set NV blocks and uninitialize. Maybe it's this one. It's probably this one. Try add chunk from calls. So set chunk calls, register. Wait, so... Oh, I can just call this directly. Right, I can just call this directly, actually. I don't have to set everything manually myself. Oh, that's good. I like that. Yeah, let's do that. Oh, that's so good. I'm glad I found this. So cube chunk cards is gonna be... We just need the coordinates to something like 0, 1, 0. Probably, that should work. From int to... Okay. So let's do vector 3i. Boom. And now it's good. So we create our new chunk. I guess, well, yeah. We have the chunk. I might need a cast. That's alright. Yeah, I mean, it's already registered the chunk, right? So that's good. Wait, it's already registered? Why is it called? Add chunk from neighbor. I mean, I guess everything is not generated at first. Like, nothing is generated at first. So that might be fine. So chunk, we have the chunk. Actually, that's... Space. Okay, so I have the space. We have the bytes. We serialize the area into the byte. And what we want next is we just want to deserialize. So let's remove all of this, and we are gonna have... well, I don't have the function right now. That's a goal. So we want to go from bytes to the area. So this is... When we have the bytes, we have in area, and then we have a out area. Boom. And we just need to make the deserialize function. Okay, good, good, good. This is not bad. Let's hope it works. And after that, we should test things, right? We should compare the data that was before the serialization and, you know, post serialization. Local vector, okay. Let's do this for... I don't have deserialize for that. Let's do this for deserialize. So deserialize. Do I want a writer actually? I mean, for now, maybe that's fine. Maybe I can just keep things like this. Wait. Wait, so... Wait, I'm supposed to do that from bytes, right? So can I just use a span? Because when I read a file with Godot, I'm just reading bytes, right? Am I? Godot read file bytes. C++, is it like cost heavy or something? Get buffer. Yeah, it's just to get buffer, right? Is it? Like if I do this, file access, get buffer, and I get a packed buffer. So something like this, please. Access, no. Well, I guess it's, yeah. Read. Well, it's trying to read everything. And it's gonna copy. That's what I don't necessarily like, but, you know. Yeah. Read. Windows, what do you do, Windows? Because I guess I want to optimize for Windows, right? Because Linux is fast anyways. And a lot of people are going to be on Windows. Fread. With the length, no. Wait. So destination. So this is the destination. Yeah, okay, that's fine. Yeah, it should be fine. So yeah, it's gonna be a get buffer. And, well, what is this again? Well, what? Destination. Right. Okay. Okay. So yeah, I'm just gonna take a span. Oh, well, bad idea. Well, output is fine. Let's just have this, okay? Let's just have this. No, input. Well, this is... Wait. Yeah, this is input. Oh, Superxan, hello, hello, October. Trying to do some deserialization because last time we managed to basically make the save, right? The save thing. Now we need to load. So we have the bytes, right? Input is just bytes. And we have the out area. Yep. Oh no. Okay. So byte out area. Good. Is it? No? Well, it's gonna be. So I mean, I guess it's... I just want this, right? I just want this. So we have all of this. Message pack, how can I read from this? How can I read from a message pack? So message pack, read data. So I can unpack, convert, but I want to unload manually, I guess. I mean, I could do that like this automatically, right? But I don't, well, I don't want this to be manual, actually. Do I? If you mean how to read. No, I don't want this to be manual because I want to process the values, right? I want to process the binaries, for example. For multiple packed objects in a stream, use a non-packer. So it's basically the same. Before I had a packer, and now I'm gonna have a non-packer. So message pack, unpacker. Unpacker, I guess this is gonna be the name. And we're basically gonna do the same. So reserve buffer. Oh, you can do that. Buffer consumed. Wait. Wait, so it's gonna be in a buffer in the end. So I'm gonna have to copy, is that it? No, because I can probably do the same as with the packer and just create this with bytes. User data. Initial buffer size. Well, maybe not. Wait. Let me check. Writer. Well, let me get that. So we have the packer, and we have the output here. So it should work the same, and instead of a write, it should require a read, maybe? Wait. Wow. Anyways. Maybe I should move this down next to the serializer. Like that. So we have this pack version. So the first thing I want to do is unpack. Oh, I can't. I guess start, buffer. Oh, there's a lot of things. Visit. Start array. And it's saying reserve buffer, get buffer. What about if I search for buffer data? I mean, I have end array, start array, and that kind of stuff. So maybe start array, array item, map key, map value, no. Data, no. Next. Visit, I mean, maybe visit is fine. Maybe visit is what I want. So just a visit version, so visit int something, positive integer, negative, float, positive integer? I mean, I can have both, so wait. What is X? I don't know what it is. Float 32. Okay, let me check. How to use the unpacker to with other things, other types, to load other types. You first get an object handle, then convert it to whatever you want. Oh. Oh, literally, oh. So if next, so basically I'm gonna have a while, custom types. Okay, I get it. Reuse an existing object. So it's point get. Well, point next, point get. Got it. Reading multiple different types sequentially. I mean, I can do that. I mean, I guess I have an array. Do I? I actually don't have anything. Oh no. I mean, I should start with an array, right? Because it's just not gonna work if I do that. I can't just put a lot of values without an array or an object. So let's do that. Pack array. And the size is gonna be... Well, I guess let's put those brackets just to show that we are... Wait, did I push? I don't think I did, actually. Let me check this. Yeah, that's what I thought. I didn't push. I mean, I can always do that at the end. That's fine. So we pack the array. I need to ensure that this is fine. Pack version. Wait. Append buffer. N. Yeah, it's just the size. I just write the size. Yeah, that's fine. I don't reserve, so I don't need the size in bytes. I just want the amount of elements. So we pack. Then we pack the map. That has this, right? I mean, pack this. Then pack bin. And I pack the body. So something like this. And that means I have 1, 2, 3, right? That makes sense. Yep. Should be good. Should be good. So now we need a next. And next returns a handle. A message pack handle. Oh, that's why it was it's object handle. So we have this, we pass it inside, and while there is a next, it returns true probably. So we're gonna loop. And we're gonna check if this handle. Well, we're gonna check what this handle is. Point get, set, and zone. What is zone? What even is zone? Is it like I don't know. I don't know what this is. Finalizer. Oh, that's the end. Maybe. No, I don't know what it is. That one, okay. That's the region where it starts in memory, probably. So get. Sup, hey, Francesco. How you doing? Doing well. Thanks. Trying to... You know, basically last stream, I managed to make a serialization function to save my chunks, right? Or like my structures, because I can copy and paste them. And now I'm trying to save them. Well, not to save them, but to load them, right? I made the save function, and now I'm making the load function. Francesco! Virgorini! El capi di tutti! Capi! I can't make a good voice for that. I can just roll my R's. I couldn't as a child, and that was very embarrassing. Especially in Spanish classes. El capi di tutti Itari! Perfect, is it? No, it can be much better. But yeah, like, look at this. This is so good. I can just make a wall. I just love that. I just love that so much. Wait. Yeah, I can make my... Oh, no. I love that so much. I can copy all of this. And I can paste it. This is just so simple to make things. Anyways. Let's go back to the loading. I'm just so satisfied with my copy and paste. Nailed it. But my nickname is not for Francesco o Virgorini. It's because in Spanish my name is Francisco. Oh, Francisco, not Francesco. Got it. I'm Argentino. Oh, I see. I was gonna say something. I was gonna say no hablo Argentinian. We have type. Wait. Frero! You started mixing up L and O like Japanese. Yeah. I mean, I do like rolling my L's because of Japanese, right? But yeah. I have 3 half brothers and they are overseas. Australia. Oh. Wait, that's... I was gonna say that's very far away, but... Well, look at this. Let me show you what I mean. So that's like very far away, isn't it? It's not as if you could just go this way, right? Oh, a nudge. That's fine. It's very far. Yeah, I actually don't know if you can go this way because I don't know if it's like well, I don't know about like the roads, right? The maritime road. It's still far. Yeah, I mean, I guess so. I guess it's actually almost the same size. But then, well, yeah. Use osm.org, sure. Because I guess it's spherical, right? Like the planet is spherical. So for example, this line is bigger than this line, right? Welcome back. Oh, that's Japan. Wait, is it? No, my address. Wait, what? Wait, is this really my... Wait. Wait. Anyways. So, let's do... Okay. Whoa. So let's do... From... Okay, let's go from... Here, from Australia, to the other place, right? So it's like far away. It's like over there. Wait, it's like over there, right? To here. And you can just walk there, actually. You can just walk there. You just have to walk on the sea floor, but... Oh no, you can't, actually. You can use a car, though, to go to Australia. You just have, to... Wait, so how can I check for, like... It's huge. Wait. Here is winter now. Yeah. In the same hemisphere, yeah. Australia... Well, it's gonna be winter... Like, winter is gonna end soon, right? Isn't it? Australia is almost a continent. Yeah, I mean, technically it's a continent, right? So can I just use... How can I trace a line? I can't trace a line. Spherical world map line. Trace. Wait. Map. Well. I mean, I guess I can just use Google Map, actually. I hate how it's just showing my coordinates. For some reason. Let's be careful about that. Coco Cara. Coco... Wait. Yeah, let's just click on China. So we have this, right? We have... Where's the ruler, actually? Kyoyu... Fukukara no ruto. Okay, to China, that's fine. And we have... I thought it was showing my coordinates. So, Brazil. Argentina. Argentina. Wait. Was it this? Yeah. Argentine. I don't know how to say it in English. Wait. Can I just click? Wait. Go here. Maybe this. Wait, what? How can I trace? Butler, hey, sell. Wait, how can I can't right click. Coco Cara. And okay, never mind. And Coco. Well, and then I click. And then I. No do it though. Wait. Ostradaria. Okay, I don't know how to do that. So. Okay, that's complicated. Like this. Did I do it? You know what? Oh, no, that's it. That's good. It's working. But there isn't any plane. Wait. Wait, how can I have the ruler again? What's this? But we're trying to measure some size on Google Maps. But wait, is it this? Clio, okay. From this to Kokomade. What the fuck? What's going on? Oh. Okay. Well, you can just do that, right? You can just do that. Oh. Do you know some site or forum where you can develop fast software and get paid at the moment? I don't. Wait, you wanna be paid to program? Wait, you can get money for that? Wait, why am I? Oh shit! You can get money for programming? Wait, how do you do that? Oh no! Let me find how to get money while programming. How do you actually make money programming? Oh, digital products. Freelance? Yeah, I guess freelance. Web designing? Yeah, I guess web designing works very well, apparently. But I'm not into web development, so I don't know at all. But I think it's like, you can get some nice money. It's a myth, I want to check. I mean, I guess. I mean, there's something called, there are like some websites for freelance. How is it called? Vevatek. Right. How to become... Yeah, okay, I know it's Japanese, right? Is it? Wait, Rebatek. Because I'm hearing that all the time. But I actually don't know if it's like Japanese or if it's like, if you know it too. There's like an advertisement about that. It could be a fake news. Wait, you can also make money from gaming companies on freelance that hire some programmers. You could, but I wouldn't really... I mean, it depends. Not big companies, because big companies already have somewhat... Well, they're like delegated big companies that already work on, you know, outsourcing, right? So, like, usually big companies, like famous companies, already have, like, an outsourcing company they know, and that they are kind of working with. And, you know, yeah, usually it's like, it can be a long, like, contracts can be a bit long. I mean, it can be short too. And, yeah, usually it's like not a solo programmer. But, I mean, yeah, you can just get hired. some people said on internet that there's such practice as money for developing software. It could be fake news, it could. It looks like it's the same distance from both directions, if I'm not mistaken. Wait, is it? Thanks for the raid! Hello, hello! You can be part-time... you can be a part-time course teacher for websites. Yeah, it's actually good. Thanks a lot for the raid. Let me give you a shout-out. And thanks for the... Oh! Never mind, it's not a follow, it's a ho-ho! Mukate kuru no ka! Kono plugs ni mukatte kuru no ka! Dewa, jubun shikazuku ga yoi. Do I actually have the game? Okay, let me show you the game. For the ones who just joined. We have some kind of voxel game, like this, which is actually a donut. We actually have a giant donut. We can place some blocks, we can destroy, and we can build something like this that we can then copy, paste, right? We can paste. And then we can, if we want, copy again and paste it again. That kind of stuff. And the goal is to save... Well, the goal is to load, actually, those things now. Because we did the saving last time. I also want to add some more tools after that. For example, rotation. Or what? Or removal. Right? That would be nice. Or maybe a fill. Fill too. Anyways, so we have this. So now we get, how do we actually parse this? Boom. We're doing multiple different types sequentially. If you pack them like this, then unpack. Well, unpack? Wait. So yeah, I can unpack them directly like this actually. Right, because it's an array. Wait. Message pack. Can I pack... Wait. Can I pack directly everything sequentially without having an array? Well, without then being in an array. Can I have that? Oh yeah, I can. Oh, so I can do that. Buffer consumed? What? Oh, unpacker. Never mind. So, okay, let me actually remove my array, I suppose. I mean, technically, if I have JSON, that's what I should do, right? But I don't have JSON. So, okay. And then we have feed buffer data into the packer. Okay. I'm not sure about that. Unpacker reserve buffer. Oh, no, okay, I get it. So then we do this point next, and you can get the value. With templates. Got it. So get as like this point next. Wait. Well, okay, let's not do that. Let's do this. Handle. So then we can get as. Yeah, as. And we have different things. So it's gonna be an int, maybe? Int 32. Maybe. I hope it's gonna work. And it's gonna be the version. Oh, is it? It's gonna be uint. And this is the version. So next we have... So version. So then we have a map. Ooh, a map. Let's get this. Let's do as well. That's not gonna be good. The format becomes order dependent. Yep, I know. So what about get map and get bin? How do you do that? Oh, it starts map, right? I told the function before. Get a map. You can also directly convert. Get binary data. Wait. So what about the start map? What was that about? Like next? Wait. Oh, maybe it's like to create. Start array and start map. Start map key. Oh, so it's a check. It's to verify if the current pointer is onto the start of a map. Or something like that. So we can do if handle. No. Well, handle type. Let me check this again. Type equal map via. So type equal message pack type map. If it is, well, I mean, we assert, right? So it should be the case by default. So we have this. We have equal. Like all equal. I don't. That's fine. So if it's not equal, there's a problem. And we return false. I mean, technically, it might fail. Like, if you corrupt your save file, then technically at some point there might be a problem, right? So I don't want it to like crash either. I just want it to return false. With like an error, I guess, for now. You know, for the logs. It's fine. That's actually one of the only cases where I actually want to use the macro from Godot. And have it be safe. Have it stay safe at runtime. So we have this. Then we have object via map. Is it this? Wait. Via. Yeah, what is via map? Is that a union? Oh, if it's a union, it's actually smart. It probably is. I'm sure they're really smart people. It's a union. I knew it. I knew it. I knew it. Nice. So we have the size. That's gonna be. No, that's not what I want. Well, why is it? Why is it, huh? So we have this. So we have the map. Object map. It's not there. It's there. We have the size with this type. Then we have the pointer after that. So size equal this. Maybe. Expression preceding parenthesis of apparent call must have pointer to function type. Do I have to include this? Is it not included? Object.hpp. Is it good? V1 object. Wait. I guess I have to include this. But it's like a header. It's like header only, right? Yeah, it's like including everything. It's like including everything. I don't understand. Let's recompile. But yeah, talking about other things. I did see there was like someone on Discord that just joined like yesterday, and he's making another voxel engine. That's like pretty interesting. And I'm kind of curious about you know what there is, like how it's implemented and stuff. Right, like oh, a new sub, nice. On YouTube. So yeah, this is gonna show you. This is a guy. I remade Minecraft, but 16 times smaller. What? Hi. Well, small. Right. Yeah, I mean, this kind of stuff, right? It looks pretty nice. I feel like I'm very far away from this, but I did spend a lot of time on my donut. Right. So errors. Add signal. Too many arguments. Or there. New and old. Wait, how is it too much? Add signal, it's only one. Wait. But... Wait. Method info. Or is it because of this? And I need to put my property info inside instead? Wait. So return type. Wait. Which one is it? Method info. Return type on new chunk. What? Name. Oh no, yeah, that's yeah, right, there's like multiple overloads. So name and params. So it should be here. Let's have this. Should be a bit better. Hopefully. Have some names. And now we have... Does not take 0 arguments. Oh! Wait. Temp does not evaluate to a function taking... Wait, where is it then? Oh, is it just a single value? Oh! Right, it's not a function. It's just directly... Boo. Size, right? It's a variable. So we have the... Wait. We have the size. So then we can have the map. Let me check not this. I'm gonna close the Google Map and stuff. World map. I'm gonna click this. Okay. So then we have the map pointer. That's gonna be this. And it's an object key value. And then I can count and I can access this. Okay, so let's do that. It's message pack, objects key value, and it's a pointer towards this. So we have the, basically it's a map, right? We have the map, or actually more precisely, it's local voxel map. And I don't actually have to pass it into like an actual map. I can just directly use this to convert back. Well, bad idea, isn't it? I'm not sure about that. Let me think, what should I do? I mean, in any case, I'm gonna loop over this, right? Int 32, I equals 0, I less than size, I plus plus. But then I have this key and value. So key and value. And then I do stuff. And after that, yeah, we're not gonna actually load the map, not now. But it should be from... Well, let me think about it. Oh, no, I know what we need. I know what we want, maybe. I don't know. I actually don't know. Do I want to load directly onto like the world, for example? I mean, maybe a map, maybe creating another map is better. Yeah, and then we have the bin. So the bin is gonna be the same, right? It's gonna be something like next. Wait, do I want to go next here? No, I don't. Something like this. Probably. And then we want to ensure that this is binary. So, like this. And we are gonna have, well, kind of same handle, all of this. But instead of a map, it's gonna be bin. And we have the size, and we have the pointer, right? Good. Pointer is this. Good. And okay, this is good. And now, pack bin. Wait, pack bin. And B blocks. Oh, that's fine. I forgot to save the size, right? Like the dimension of the area. Yeah. Good enough. I just realized, but I don't need all of this data. Well, I don't technically need to store the... Okay. It depends. Let me think. Let me think. Basically, I don't need to store the size of the binary because I can retrieve it with the blocks, right? Can I? Yeah, I can. But anyways. So, deserialize. We have all of this. And what I want really is get compressed. Wait, do I? Well, and then we have the serializer, right? And we should have voxel array serializer and a deserializer or something like that. Something like this. Well, maybe not this directly. But close, right? Like this is about... Wait, what is it about? This is about array cube chunk storage. And I do have the deserialize function that I might want to put into another class too. Actually, I mean bytes. I mean I can just take a span too. A span could be enough. And if I have a span chunk map, well. Storage size, out storage. Well, maybe not. Yeah, let's do this. Let's clean this a little. Maybe. So I need the deserializer. Do I? Wait. So I have all of this. I can push. What about a read? Because I have the current byte and stuff, right? Local bytes. Well, well. I could have this in the same class, but then I don't want bytes. That means, or do I? Because I do want to resize potentially. Let's make another function. Another class, I mean. Deserializer. I think that's for the best. So the amount of block types, good. And the amount of blocks, that's all we need. And we have, instead of a push, we have a read. Maybe a next. No, just a read, that's fine. So read. And instead of pushing an ID, I'm gonna retrieve the ID. Like the block, right? So it's gonna look like that, and instead I want to span. I want to span. Good. And now let's go in. Wait. I can copy this. Technically, some things are gonna be a bit similar, but that's fine. Bytes resize? No, no resize. I want the span though. Unit 8. The span. Like bytes, I guess. Yeah. I actually don't need the amount of block. Well, no, I do, actually. Never mind. So I have this. I guess this should be like the first thing I should put. Block types, blocks. Okay. I mean, any... Well, okay, never mind. That's good. Oh, wrong. Wrong one. Okay. Oh. Count. So... No need for resize anymore. Wait, what did I do before? Nothing. I thought I removed something, but I guess not. So I did this, I have the amount of bits, I have the amount of bytes. And that's what really matters. I could have this inside a single function, right? Get bytes and get bits. But yeah. Then I want to read into the integer. And that's when things are gonna be a bit different. Do write serialize. No. Deserialize. No. Not yet. So many things. Okay, so we have this. We have NV block types. We have the amount of bits. So that should be the same. Like 32 minus count L0. This minus 1. Yeah, okay, this is the same. Then we resize. Oh, for the output. Well, not necessarily, right? I don't have the array. And bits. Wait, I don't even need the bytes. Current byte plus plus. Wait. When is it stopping? This point size. Storage size. Oh. Well. I don't really care about that, do I? Well, no, no, that's important. Is it? No, I have the amount of blocks. Right. Not bytes. I need the blocks. And for each blocks, I'm storing bits. Okay, that's fine. That's good. So, NB blocks. Yeah, that's good. Yeah, that's good, that's good. Good. I'm gonna remove that. And I'm gonna have a copy of this. Wait. Read. I mean, I guess it's a read. So we just want this for each bit. Current bit, current byte. Boom. Wait, no, not that. Here. Voxel ID. And I can just return this. Okay, I mean, it should be good. That should be it, right? Resize and initialized. Wait, am I missing something? No, I'm not. I thought it was gonna be a bit harder, but I guess not. Let's just make sure we don't have any problem. Deserializer. We need bytes, NB block types, and NB blocks. So bytes, NB block types, and storage size is actually NB blocks, isn't it? Yep, it is. So we have this. So I can remove this technically. And bytes is this. So just gonna convert this to a span. And yeah, the nice thing with spans is that you can... It's basically a view to read an array, but, you know, just with a pointer and the size. So you can basically, as long as it's contiguous, you can basically convert any type to a span without a copy of the whole array. So that's why it's like pretty good when you want to just read a contiguous buffer, because it's like polymorphic in a sense, right? So then we have this, and for each block we have the read into a uint32, and we set. Let me just check something. Yeah, it's inside the loop, so that should be fine. That should be fine. Serializer. Right, so I mean, I still have to test if this is working or not, so I'm just gonna build, and I'm gonna try to run the unit test again. Well, I mean, I guess I was making a unit test myself. So, well, it's actually not doing anything, right? There's no comparison, so it should be fine. Well, I mean, technically there, well. Warning. Let's go there. The tool path return right. So let's do this by default. It should be good. Okay, let's go back here. Wait. Serializer. Let's go there. Warning. Exception handler used. But unwin semantics are not enabled. Oh! Unwin semantics. Okay, I see what it means. Got it. Can I just remove that then? No, I can't. Try catch. Not all paths return. Let's say it returns true. Okay, success. Let's go here. Open. And let's run test. Wait, it went too fast. run tests, point back. Wait, what? Main. Wait, tests. To be able to run unit tests, use the test equal yes. Oh no! Test was specified on the command line, but this Godot binary. Oh, okay, my bad. So I need to rebuild the engine with tests. Let's go there. Oh yeah, that's what I used last time. Let's use this. Test equal, yeah. Boom. So we're gonna have to wait a little, that's fine. In the meantime, I want to check some other things. So we have the binary. And we have the deserializer. So yeah, it's gonna be a deserializer instead. Like this. Deserializer. And I actually want to check NB bits. Current bits. So this is uint 8, that's fine. I guess that should be... Should it be 8? Maybe not. Wait, maybe yeah. I mean, it's just a bit, right? So yeah, maybe just 8 is fine. It doesn't really matter really, but... uint 8. And now I want to... So basically right now, it's not gonna be packed because uint 32 and uint 8 have different alignment in memory. So if you want to pack your data properly to reduce the memory cost, you have to put those types next to each other. Okay. Nice. And I mean, same here. That's gonna be the same here. Deserializer. Bytes. I mean, it's basically the bytes we have, but as a span, right? And then we have the amount of block types, which is just the size of this, right? So local voxel map size, that's gonna be. And we do this. We do this. We reload with a save. And now we should be able to run the tests. Are you ready? Wait. Is it here? No. It's here. Let's go. Shit. Wait. That's what's specified on the command line, but its Godot binary was compiled. Wait, what do you mean? I compiled it properly this time. Oh no, I have to recompile it. Oh, right. Build. Here we go. So we have this. Let's just remove that for now. So now we're gonna work again on it. So the amount of blocks. Yeah, what is it going to be? Wait, I actually don't have... Oh, my bad. Right. Okay, my bad. So, yeah, we do need the amount of blocks. And it's gonna be a vector free. So... the map. Why not? Then we have... pk points pack integer int 32. Can I just put an int pack fix? I guess it doesn't really matter, does it? 32. Like uint. Can I put a uint? I can. Perfect. Uint. And it's gonna be the size. So area. Oh wait, we have wait. So yeah, it's the size. Get NB blocks. Oh, well, that's it, right? Oh, right. Wait. Well, no. Okay. Wow. Right. Right, I get it. We need to pack each dimension. So... area, like get NB, well no, get NB blocks we have, and we also want vector free I, get area, maybe? I'm not sure about that. But it's basically going to be max x, is it +1? So if you have from 0 to 1, that means they are going to be like 2 values, because max is included. So it should be +1. And we have the same with z. +1. Here we go. Something like that. I mean, we already have this here, actually. Wait, so I can technically just use this and do the times. Right, I mean, that's maybe for the best, actually. Let's do that, because it's probably gonna be optimized, because the function is like pretty short, and it's in the header, so area. Like this. And then we have x times y times z, and it's a lot more understandable. So I mean, I'm already computing the area. So technically I can do, what can I do? Get area and NB blocks. Can I just have both? Because I want to reuse the result of this. But it feels a bit much. I can just compute it too. Again, well. No, let's just do something like this. I mean, it's gonna be in lines, right? So compiler is just gonna optimize probably. That's fine, that's fine. Vector free I. Block, well, voxel area. Well, I don't like this name. Yeah, I don't like this name. How can I call it? Per axis, maybe. NB blocks per axis. Good. This. And now I can store this. And then this. And then this. And whether it's a uint32 or a uint16, it's gonna call the same thing, isn't it? Kind of, right? Unsigned 8, for example, that kind of stuff. That's good. Yeah. It does not really matter. I mean, I guess there's like one more condition. But yeah, that's fine. My god, hey Yoda, hello. What is it? I didn't see you. Okay. So now we're gonna have to load this before the binary. So right here. It's gonna be next. And we're gonna make sure this is fine. Well, make sure this is fine. Make sure the type is right. So this is gonna be... Well, let's just copy all of this. This should be an integer. Fix int... Wait. Fix? Just positive integer, right? My brain told me that meant hello, but it means my gosh or something. Yeah. Well, I know that means, I mean, that means hello. You just addressing to me as, you know, a higher being. Okay, positive integer should be fine. And if it's not, then it's not good. Okay. So now we can do x equal type. No, not type. Via int. Wait, I don't actually have this. U. Oh, U. Oh, U64. Maybe. What is that? It's just an integer, right? Wait, so how can I access it? Wait, can I just do... or as? Oh. Wait. Can I do that? Via U64. So it is good. For a known unsigned type. Unsigned value. For a known signed negative value. Important, does not preserve your original C++ integer type. If you pack, it may unpack as this. Yep, that's good. So if you're manually using VI, you generally need to handle both positive and negatives, I know. So as int32 is good. Got it, I'm gonna try that. Yeah, I guess it's first best. Well, no, well, as uint is better, right? Because I know it's unsigned, and since we know it's unsigned, that means there's not going to be the check for whether it's positive or negative, right? Convert. Wait, what? I'm not sure about that. Well, let's hope that this is good. I'm wondering how much would you charge for C++ lectures? I actually gave some lessons for that before to some viewer. He just came to my DMs and he was like, hey, can you give me lessons? And I was like, hey, yeah, sure. It's gonna be 1,000 euros per hour. And that was the deal. Kind of. Maybe I'm exaggerating things a little, but yeah. I mean, what do you want to know? I can just answer some questions on stream if you want. Just anything is fine. Well, as long as I know it, I guess. Maybe I can't really answer much about web questions, for example. But if it's linked to video games or C++, I'm good. I can give you my Berserk copy. Your Berserk copy. That's fine. So, I mean, I should make like a function or something for vector 3i. I feel like I'm gonna use this a lot. And z. So, like this. Kind of. Oh my anime Eren Yeager pillow. Okay, we might negotiate something. Is it smelly? Just kidding. Just kidding. MV blocks per axe. So we have this. And now we have the amount of blocks. Wait, I just need the integer actually. Oh no! Wait, what? No, well, no. This is good because I'm gonna need this afterwards anyways, right? So now that we have this, we just need the times. So this point x, y, z, right? And v voxels equal this. Boom. Actually, I have to place my vacations, I forgot. Okay. So we pack. And we... Wait, that's not here. Wait. Deserialize. Wait, what? Deserializer. Yeah, I don't actually need this anymore. Good. Yeah, wait, so did I compile? I think I did compile, right? Let me just go back here. Okay, I commented this. And that means we should be able to run the unit tests. Or maybe not. Bytes. 2 times. That's the outputs, right? So we have storage. Initialize dummy. Yeah, I guess it's fine like this. Build. So the binary. We have the deserializer. Oh yeah, it's recompiling everything. Oh no, should I say? It's gonna take a long time. Or maybe not. So handle... No. Wait, so this is... Yes, a binary. Read. I need to read. So... Point read. Because I already have this, right? So I can just do that. Yeah. The question is, do I want to save the structure uncompressed or compressed? Well, uncompressed is probably the best for speed. And like for generation it would be nice, right? So I might want to keep it like this. Out voxels. But I'm really not sure actually. Well, I mean, should be fine. Should be good. Out proxy. Well, no, out voxel. Wait. Right, no. No. So... Right. I want the size and the voxels. Let's do that. I mean, let's run the test now. Okay, we have a problem. That's bad. Wait, I remember this problem. It's not actually unhandled exception couch. C++ serialization 30. 30? Couldn't map PC to fname. Wait. Deserialize. Oh, that's deserialize. That's fine. Is it? No, that's not. Wait. Wait. Oh, because I don't... Okay, I know why. It's because I have this, but I'm never setting bytes inside, right? I actually don't even need the amount of blocks. And... Okay. So... Bytes. Bytes equal in bytes. Here we go. And that's it. I'm also curious, are you capable of making a modern AAA Resident Evil game on your own? I mean, if I had to do that, I would probably use Unreal instead of doing low-level things like I'm doing right now. I'm definitely not good with art and that kind of stuff, but on Unreal there's mega scans, that kind of stuff where you can just drag and drop and have some pretty realistic stuff. Resident Evil. I'm not really familiar with Resident Evil much. It's a FPS game, right? I mean, FPS games... I mean, the camera is like... Well, I mean, the game is like big, right? And like, there's like characters, like you want to... Well, there's like MetaHuman on Unreal. But, you know, like the quality is... Well... You know, I would have... If I had to do something like this, I would have to take shortcuts. And in the end, you know, it's not gonna be the same quality overall as like a big AAA game, right? Because I mean, right? I'm not like a 10x programmer, maybe, or am I? I'm not a whole studio, right? Like there's the story, there's like the localization, there's like the sound. I still have to work on that. There's like the art. There's like programming, I guess. There's like tools, right? Like if you're making an AI, that kind of stuff. Like the camera is a lot of work. I'm gonna have to spend a lot of time on the camera for my game, actually. The current one. Then there's like more, well, the rendering, right? The rendering is big too. It's really big. Like AAA games often have like crazy rendering techniques to simulate, well, I was gonna say things like skin, for example. You know, for the lighting to go through the skin properly and stuff. Or, you know, like clothes. I guess in Unreal you already have some stuff like that. But yeah. I mean, Unreal is pretty nice. That's why I would use Unreal if I had to make like a AAA game like that. But I know I don't have the time to work on a AAA game on my own. So that's why I didn't go this way. And instead I'm going the Godot way with some more custom thing that I know not a lot of people are gonna be able to do, right? Like a Minecraft donut is, like you need a lot of knowledge. Like I use so many tricks. So, you know, it's because I have a lot of knowledge and not a lot of time that my goal is to make something that's very hard to make, but that's not as slow, right? That can be relatively fast. Like, even if I don't have good rendering, in the end, my game is still gonna be, you know, unique, and people are gonna maybe still want to play it, or they're gonna be curious, at least, right? Like, for example, can you go inside the donut, right? Everyone is asking that. Okay, so we're setting bytes. Let me compile again. Yeah, and I mean the playtime is gonna be different too. I think, like, for example, you have like Exploration 33, right? Expedition 33. You have Clair Obscur, right? That won like so many hours, but it won so many hours because like everyone was skilled in their own fields. Whether it's like music, whether it's like, you know, the gameplay, the story, all of this, right? And I can try to work on a lot of things, right, in different fields, but in the end I don't have I probably don't have, well, maybe I have the time to learn about every field very, very deeply and stuff, but that would be a lot of a lot of investment, and it would take a lot time. And it's like better to make smaller projects and to learn things gradually with smaller projects. That's what I did with game jams. That's how I've learned Godot, right? How I loaded member function. Wait, what? Serializer. Wait. NB block types. Oh no. Let me bring that here. So then we have the bytes. This is good. Let's build again. I do have a few errors though. Right, I mean that makes sense. Because I don't need the amount of voxels, just the map. Point size. Well, no, that's already the size. And I guess this is... Did it compile? Yeah, okay, good. Trying serializer. Oh, no, too late. I was too late. What's that? Well, let's have this. Let's go there. And I don't need the amount of blocks, just the amount of block types. And deserialize, so then I can do stuff. Out storage. I guess I can have that. Out voxels. When I say I'm not gonna have enough time, I mean that it's gonna take either my whole life or more, or either something like 15 years, right? Or I don't know, maybe not 15. Well, it depends. But like in, you know, at least 10 years. And the thing is, tools evolve. And like 10 years for a game is way too long. We might not even be on Windows anymore in 10 years. We might all be using Temple OS instead. Out voxels. So yeah, let's loop. I equals 0, I is less than NV voxels, I plus plus. Then I have all of this. I mean, yeah, I can basically get the ID, right? That was the goal. And now I also have the map. So I'm not sure what to do. What in the holy heck? What do you mean? I'm not saying I can make like a AAA game without learning anything. I would need to learn, you know, more stuff, like music and stuff. Sound effect, I guess, a bit. Art. That kind of stuff. Like making models. I really want to make models. And I guess I do want to... Well, I would need to learn 2D too. But well... Yeah, that's a long time. Like, just learning all of this would be like, you know, a few years at least. And that wouldn't mean I would, you know, I would be good at it. Set ID. So yeah, we have the ID. Let me think. I mean, maybe that's fine. Maybe that's fine. Or do I want to convert directly? No, I probably just want to deserialize. I will use the AI OS server hosted by the AI company on a monthly payment in 10 years. Oh no. Oh no. Yeah, I don't have this. I don't have the space. And I don't want the space. So I guess I don't want to output a space. I just want to output stuff. So I need a map. Well, I have the map. Well, let's make a struct. So we need a vector That's gonna be voxels. I need the size to do all of this. I need the map, the local map. So that's the size. Well, I guess I need to read this too. I will use it. To be fair, you're trying to do Minecraft and some Sekiro-ish mix. That's pretty big. Yeah, yeah. I mean, I guess you could say it can become AAA. I just need to work on the graphics, right? But that's not the priority. But technically, it could become AAA. Given enough time. And I know it's gonna take some time, right? But yeah, I don't have like an end date. Maybe that's the problem. But I don't want to continue working on this. I don't want, because even before college, like in high school, I wanted to make my own Minecraft. And I want the freedom to do whatever I want. And yeah. And what I also just want to do is get some keys on Steam, right? Some free keys, and just throw them on the crowd. And say, hey, peasants, take my keys! Take my game! I'm kidding. But yeah, I guess we're gonna have a map. So, a hash map, I suppose. What do I want? I want a conversion map at some point. So... Nope. Nope. Then you think about how I'm going to implement this. I mean, it doesn't really matter, I think, what order I go. So I guess from uint 32 to a string name is fine. Like voxel ID. Oh, actually. Yeah, it's a local map. So it starts at 0, right? So that means I can just have an array. Local vector of string names. And it's gonna be ID to voxel name. Good. Efficient. I like this a lot. So that also means we have a bunch of stuff. And what I can do is just, well. Let me add this here, I suppose. We're gonna have a resize. Yeah, it's gonna be so optimized, oh my god. Woo! Nice. We're gonna push... Well, technically... Wait. Yeah, so actually it's not even a map. I don't even need a map. I can just store an array. That's good. That's great. I can store an array. Let's do that. Push back. So... Wait. Well, that means I'm gonna have to save it differently, but... There's a map. I guess that's fine. I'm just gonna keep this just in case, but yeah. And this is instead gonna be array. So array, point size, local voxel name size. Just voxel voxel names size. Maybe. So we loop. We loop. That means instead of getting this, right, I'm gonna have array points pointer, and it's from v2. So just objects, I suppose. Object array. Can I just have this? No. Like this. And now I can just read this. Maybe. Yeah, I can. Should be able to, so I can just get the value. I have to check if this is an integer. A string name. Wait, yeah, it's a string. Right. So let me just assign this to objects. Have to check this. If this is different from a string, then it returns false. So this points type. And I can now just do this points string. Well, via string, PTR, and size. Good. So the size is gonna be. What is it gonna be? String name, key, like a voxel name. I was thinking about something because I'm gonna have a lot of strings potentially, and I'm not sure. I mean, basically, if every block is different, it might, like, the chunk might take a lot of space in memory, but not because there are a lot of blocks, but because there are a lot of voxel types. So I was thinking about maybe reducing the name, but I can't really do that, can I? I mean, I could have a few native types that are always going to have the same ID, for example. Like a grass, a stone, that kind of stuff. But yeah. Aside from that, I mean, can't really do much, can I? So voxel name. Wait. Voxel name, I can't resize and stuff because, yeah. So how can I create this? The constructor, what is it? Data. What? Is there like a conversion? Oh, maybe there's a conversion from string to this. But it's not gonna be here, it's gonna be in string. So something like string, voxel name, point resize, reserve, resize, uninitialized. The value is gonna be, well, the size is gonna be this. I'm gonna remove that. Am I? Wait. Yeah. I'm gonna have this. Well, no. I'm gonna have the pointer. PTR. Yeah, actually, can I just Godot CPP create string name from size and buffer? Oh no, I have to. It's in UTF, right? String name. So I have to create the string and then the name. Oh, because I can't just move, right? Because the string name contains a string. So if I move it, potentially it can optimize it. Potentially. Wait, what was it? Well, just, well, let me actually check again. So yeah, from UTF-8, it was. That's what I want. Good. So this equals string UTF-8 inline from... Oh, there are like 2 other loads. Span. Okay. What are the rest? What's the rest? UTF-8 happened 2. Wait, I used this function before, right? Oh no. No. No, I'm not. Boom, banned. So it's supposed to be UTF-8 with buffer, PTR, and then the styles. Like this, probably. So we create, and then we have string name, voxel name, something like std move, like this. Right. I actually don't know if there's a move constructor. I really want to see. So string, there isn't. A shame. There's this, but there's no move operator. I do want to move operator for that. Because... Oh, no, that's... never mind, that's different. That's a different operator. Oh, no, there is a move... Wait, no, that's for string name only. So wait. There's a constructor with string, though. So when I do that, I get a hash, I'm gonna make a pull request, I think. Because this is so stupid, because there's like a equal, right? But it could be a std move instead. It could be a std move. Well, actually, it's like a big function. So I don't know if I want to copy out of this, but well. Yeah, technically we could just move it. I mean, I could split that into multiple sub-functions. Like the hash, IDX, the while, data. If I make a pull request, it probably won't be accepted because maintainability is better than just a simple std move, I guess. That's a shame. But at least we have the possibility, right? If the engine evolves in the future, then it's going to be optimized. Okay, anyways, so we have this. Let's not think too much about that. UTF-8. I had this function here. And it's not doing anything. It's not gonna work. So I need to do 2 UTF-8 buffer. Can I just get the string? No, I can't. So this. Oof. Okay. So we have the buffer. We have the size, we have the pointer. And I should convert it to call. Reinterpret. Wait. Reinterpret cast. Unit 8. Oh, actually it's a call, I think. Right? Is it? What do I need? const car. Right. Okay, here we go. This is undefined because it's an array. Voxel name size. Got it? What do we need? Deserialize. I mean, technically we just did most things. You have the local vector there. But we just need to push. And for the serialization, that means I don't want a map. No writer. Serialize. I guess it's just below. We have all of this. And we have... Wait, deserialize, no. This. So yeah, we have a map right there. We're not gonna have a map anymore. Instead, we're gonna have an array. Yeah, that's gonna be very efficient. Yeah, I'm glad I picked message pack and not JSON. This is gonna be so fast. Okay. So it's not gonna be a map anymore. Get voxel type map. Well, I mean, I guess I can still call it map. But insert new. Oh, wait, no, never mind. Yeah, we need buffs. Never mind, this is fine. This is fine, we need this, probably. Because then we have the value and... Wait. Yeah, no, we need this. That's fine, that's fine. We have all of this. We have voxel name. That's all we need, really. And we're just gonna push this. So pack array. And we pack. So instead of 2 values, it's just gonna be a string. So I can remove this. Yeah, with the I. I don't need the I anymore. I mean, yeah, I can just remove all of this, really. But I just hope it's not going to be... Well, I mean, I'm gonna need to compress all of this anyways, right? So it does need some iteration. So that's fine, like looping one time over everything, like using a map. That's probably fine. Kind of. Kind of. I'm gonna need to compress this even more though in the future. Yeah, I mean, let's just remove everything we're not using, really. Push into this. Let's remove the map. String name, string, well, string name. Push back. So now... No. Okay. We need to output this. Deserialize, and it's not gonna be an area. Wait, is bytes actually used? Wait, it's actually not used? Oh no. Oh no. Initial buffer size, user data, unpack reference. I mean, I should be able to do buffer. Wait. So unpacker, wait. Let's check this. Next. Reserve buffer and buffer consumed. What do you mean by that? Mem copy. Do you have to copy? Use unpacker without a copy. Yep. By constructing it with an external buffer. So data and size. Good. So just bytes. So that's not gonna work. So we have instead the data. And then we have the amount of byte. Wait. Bytes point size. And it has to be cast data, right? To be cast. Well. Let's check the constructor, or should we? I mean, it doesn't seem like that's the case. I don't really know about this. A judging function that message pack object refer to the buffer. Wait, what? This parameter is passed to f. Oh! Okay, I get it. Initial buffer size, memory size to allocate when unpacker is constructed. And the size limit information. What? Unpack limits. Okay. Okay, I get it, maybe. So this is the function. It's a C function, that's why you pass the data. I don't get it. Wait, how am I supposed to implement this? True. Is that it? Is it just return true? Wait, what? Wait, what? Okay, let me check the... Well, definitely not GPT for that. So... What was the name? Message pack. Create unpacker from buffer. Oh, that's clean. Unpack a new. Oh, that's C# though. Unpack C. I mean, that's fine. Offset, buffer. C. Wait, what? Never mind. So wait. Huh? New offset buffer. Execute. I don't get it. Unpacker. Oh, there's a documentation page for that. It's in wiki. Oh, I like that. Accessing unpack data. Some function. Wait. Object handle. When you call unpacking functions, you need to pass the message pack object handle as the arguments. Here is object handle interface for clients. Okay. Example. Shadow. Okay. Get the zone. It's a move. Wait, it's a move. Wait. Oh. That's nice. Have you built a console debugger with its parser before? I mean, I've worked on parsing, and I've worked on... Yeah, I mean, yeah, no, actually, definitely, yeah, I worked on, well, a console debugger. I mean, it depends what you mean by that, because I've worked on, you know, consoles like error consoles. I've worked on some kind of compiler. I've worked on, you know, that kind of stuff. So it's not like precisely maybe what you mean, but wait. Copy assignments of the shadow copy is constructed. When it's destroyed, we have the it becomes dangling reference. You need to keep the object handles lifetime as follow. Well, I mean, I'm not gonna do that, right? Because I have to uncompress things. Well, actually, it depends. Well, that's fine. That's fine. Client controls a buffer. Has prepared a buffer that contains MSG pack format data. Use the following instructions. Use the following functions. Wait. Client controls the buffer. Data length. Simple. So how can I just pass the buffer address and length? What? Oh, well, no, I want the unpacker. Limit size of elements. No. Overflow. Ah, right. String being the zone. Can free a buffer that contains message pack format data after unpacking. Like a dev types into game console, enable cheese1, and it gives you and it gives the commands as you type. Oh yeah, I guess I did something like that before. Yeah, I mean, I did that for Minecraft because I made plugins for Minecraft, right? And you do have to. Well, I guess that means I didn't make the console itself, right? But like, if you add custom commands, then you need to, you know, register the command and register the different possible arguments and that kind of stuff. So I guess I kind of have an idea of how it looks like. Unpack reference function is like this. So then the memory layout as follows. Okay. Message pack controls the buffer. Oh. Unpack. Yes, that's what I want. It's suitable for the following motivations. Message pack data is trapped, and the client does not know when it will complete. No! This is a typical situation when you develop streaming applications. Oh, right. You want to minimize copy operations without careful... Well, wait. Minimize copy operations without careful memory management. Well, I guess, yeah. Here is the basic not all interface. So, reserve buffer. And buffer consumed, I guess. No. Here is a basic pattern using unpacker. So you have the unpacker you reserve. Wait, block until input becomes readable. Okay, then you reserve. Try read size, and then you read. Inside is a kind of IO library object. Read message to message pack unpacker internals buffer directly. Wait, but you... Wait, what? Wait, what? Unpacker actual consumed size. Wait, where's the buffer though? Passing process is proceeded and the context information is preserved. It helps leveling the load of pass. Okay. When message pack message contains binary data, string data or X data, They are not copied, but referenced from object, but from the object by default. Is the following implementation defaults? Well, I guess you can also customize. Yeah, that's what I want. Even if you use references, you don't need to control buffer's lifetime. The buffer's lifetime is controlled by message pack using the zones finalizer array and the reference counting mechanism. So in most cases, the default behavior is enough if you want to control the peak of memory consumption when receiving message pack data patterns are predictable. Customizing unpack reference func might be useful. Peak of memory consumptions. I mean, I want to prevent copies. Is it preventing copies if I guess it is supposed to, right? You can get a reference information from this. Oh. If you want to know the size were written when X supports an unpack reference func was not implemented. Whoa. I can't read that. I'm blind to slides. Change the world, my final message. Goodbye, goodbye, goodbye. Thank you, you die. Was fun. Yeah, I mean, I just want the syntax. So I guess I just have to set this. I mean, I'm reading, but in the end, there's nothing better than just reading the code, right? So I should be able to do that. I'm just gonna copy this for now. And go here. Unpacker. So we are gonna have message pack unpacker. And we have the reference function. This. Which is gonna be a lambda, right? As long as we don't capture anything, it's the same as the C function. So we just need an argument, or like multiple arguments, I guess. Like that. Perfect. Wait, do I have to return a boolean? Okay. So true, I guess, by default, maybe. Unpack reference. Maybe. So we have this, then we have the user data. The user data is going to be the buffer. So user data equal this. PTR. Then we have, that's null, yeah. Buffer size. Init buffer size. So this is bytes point size. Oh, it's const, right? That's fine. Is it? Well, I don't know. Well, I actually don't know. Yeah, maybe that's not gonna be good. Because I also need an integer to read, potentially. Wait. Well, never mind. I don't know how it works. Unpack limit. Yeah, I don't know what this is. Unpack limit. What's that? Array, and no. Whoa, that's a lot. I mean, I guess that's fine. Maybe. Okay, that's the limit of the size of anything. So maybe I'm gonna put a limit so I don't load something forever. I don't know. That could be useful for networking. What is this? Init size? Wait, that's not a lot, is it? That's not a lot at all. Well, let's say that's fine. No, that's not fine. So initial buffer size. We have the initial buffer size. Yeah, I mean that's good. That's what I have, and then you have the limit. That's good. So we have f. Then we have user data. Then we have initial buffer size. I'm gonna have to rename this. Well, buffer size maybe. And what's wrong? Const void. Yeah, that's a problem. Is it? Wait, what? Const void? Oh, it's const. Oh, wait. It's the v2. You have v1 unpack reference function. Void. Wait. What is that? How is it not good? What do you mean? What do you mean? Is it something from here? No. What? How is it not good? No instance. Unpack reference func. Const void Thor thic. Okay, it's because it's not const. Right, I forgot about that. So we need something like this. And yeah, I mean, that's a problem. I mean, I guess I can have like an object here. Bytes. Maybe I can just pass bytes actually. Yeah, maybe I can just have like user data. Wait, buffer size. Wait, let me. So message pack unpacker uses a callback function. Well, uses unpack reference func in here. Well, in its constructor. How to use. I'm gonna read the comment, but yeah. Zero copy reference counting ownership of the input buffer. No, that's not. It is actually. You can use it to tell the unpacker which parsed objects should reference its input buffer instead of copying that data into the zone. The zone! I mean, basically anything, right? For example, this, then we do this with null. This callback is called for variable size objects such as this. Okay, yeah, I know that. Well, I don't actually. I didn't know. So it's like referencing, so that's good. Does not let you give unpacker your existing buffer. Yeah, it does not. So wait, you still need to feed data into the unpacker with memcopy. So does this steal a copy from your original buffer into the unpacker's internal buffer? I hate that. I don't like that. The callback only controls whether parsed bin/string payloads are copied again. So unpack is what I want instead. Persists directly from your memory and advances offset. Oh, I've already. Oh, yeah. Oh, so unpack. Wait, I can just unpack directly. Oh, I get it. Oh, so I can do message pack, unpack, results. Okay, that's what I want. And if I do pack, it's a stream. So it's kind of the same. Okay. What about pack? Is there like pack map or something? I don't know. Like map? Well, no. Okay. So unpack. Let's just unpack. So unpack. We have the. Wait, what do we want actually? Okay, so it returns the object handle. That's nice. Let's create it beforehand because you're gonna assign it every time we unpack. So we have the buffer. That's gonna be bytes. Point PTR. Then we have bytes point size. Unpack reference function. User data and image. Unpack reference function. Let me check what this is, but I guess if it's not by default, then I can use it like this. What is that? Type of reference. Oh no, that's okay. So that's what I had earlier too. Okay, so that's fine. I can just have this. Unpack. And it doesn't match because I have to. It's a car, right? Const car, yeah. Reinterprets casts. Const car. I'm optimizing this so much. I don't even think I need to go that far, but I mean, it's gonna be good, better now than later, because I do need to save anyways, whether it's like for networking or for saving on the disk, right? So we unpack, but data and length. Pointer to the buffer and the length of the buffer. That's not good, is it? So, is it? Wait. Unused documentation. Returns object that contains unpacked data. So it's just referencing the thing, right? And now that I have the object, what can I do? What can I do with that? If I saved multiple... Well, if I have multiple objects in my buffer, how can I read multiple ones with just MSG pack, unpack to prevent copies? Use the offset overload. Oh, there's an offset overload. It advances the offset after each object, so you can pass multiple concatenated objects from the same buffer without copying the input buffer. Okay. So, offset. How can I update the offset? Wait, oh! Right, it takes a reference and it's updating the reference, isn't it? Each code uses the same data and size. But offset is updated. Yeah, that's what I thought. You can make it generic. I can. That was what actually I was thinking about that. That means, I mean, yeah. I'll pass until the end. Nope. Lifetime rule. Does not copy. I know. That's fine. I like that. Keep the corresponding banana alive as long as you use objects obtained from them. I mean, good enough. Good. Yeah, I like that. I like that. So I'm gonna remove this. Oh. And I'm gonna have auto unpack equal this, where I'm going to just do that. That's fine, that's just a reinterpret cast. It's basically free, right? So we want byte. And we're gonna have the offset. Is that an offset? No, I need the, okay, size. So that's gonna be here. Offset. Can I just have it like this? Offset. And it's gonna update the offset. Maybe just a copy is good, actually. Oh, maybe a copy is fine. Can I just add an object inside? Like add a new size, basically. Can I just do that? Wait, size T. No, it's not working. That would have been great. So let's do that. Offset. So we have the offset. Yep. And now we return. So it's going to do this. And I guess that's gonna be it. Yeah, that's a lot better because before I was doing next every time anyways, right? But I had to put the handle too. So now I can just do unpack. And I directly get the object. Yeah, that's great. Let's do that. So I'm gonna remove it. So I can remove this next. I can do this, unpack, as... Wait, I can't. Wait, what? Oh, it has to be a reference. Wait, object handle. Yeah, that's just a handle, right? Yeah. It's a pointer, right? Object and zone. There are like two things. Unique point. Wait. That's kind of bad. Wait, so object handle. Oh, get. I have to get. What is get? Oh, what's inside the handle? A reference. So if I don't want to copy the handle, wait. I can just do a get. Is what it means. Like if I do these points, I have get, I have set, and I have zone. I don't need any of that. I'm just gonna get. It's gonna be objects. Is it? Qualifier drafts. Like this. Good. Good. So I unpack, and I read the integer. I mean, it should be an integer. If it's not, then is there going to be a crash or something? I don't know. I could have the handle before that, I guess. Like, unpack. Well, it seems like I can't. Well. Okay, that's a bit of a pain. I could have a pointer instead. But I don't think, yeah. I mean, maybe a TD reference? I don't know. Bad idea. Is it? Can I reference wrapper to an int? And do G points? No, I can't assign it afterwards. Yeah, I need a pointer maybe. Like basically something like this, right? Unpack. What is it? What is this? Well, it's not returning something like false. Maybe get is important though. Well, no, maybe not. I'm gonna keep the handle. I feel like keeping the handle is a bit more clean. It doesn't. I don't mind if I copy like one more pointer or something. I have to finish this at some points because I'm spending way too much time on this. So we have the handle, and I'm gonna unpack. It's a deleted function. Oh yes! Yeah, I can't copy that. Good. What about this? Okay, good. Yeah, okay, no, it's a reference. Okay, well, that's the problem, isn't it? So point get, point as. Okay. Let's do the same Well, let's remove that. Then we have... Well, I mean, I guess I need the handle. Wait, I can't copy it though. Wait, what did I do before? Wait, what? What did I have? Object handle. So I had this. Can I just unpack? And I sign? I can't. I don't get this. I can't just copy. Because there's a unique pointer, but please. Maybe this. Bad idea, isn't it? Yeah. Okay, maybe I wasn't. Maybe that's fine. Maybe I can just have objects. This is a pointer. We are gonna have the point get. This is an object. This is gonna be a pointer. We return the pointer. Or maybe not actually. Just this. So then we unpack. Wait, is it good? Because the handler... Wait, it's a... Wait. Object handler, right? It has... Oh no. Yeah, I need to keep the handler because this controls the lifetime of the whole object. Doesn't it? So I want to... Okay, that's it. Yeah, I'm gonna take it by move, basically. Okay, yeah, I have to take it by move, and now it's gonna work. Good, okay, let's do that. Because it's a unique pointer, so that's it. So handle, let me just have this here actually. We're gonna do this instead. It's still a move, that's good. So then we have handle get as. So we get the version. Then we... Wait, I just removed this, right? Like I need another unpack. We unpack an array. So we have all of this. Type, you can get what's inside. Maybe. Yeah. Then instead of next we have this. This. Here we go. And at the end we have this one. So then we can read a bunch of stuff and we can output it. So instead of out area, as I said, I want this. I want this. Is it? Actually, this is a span, right? I can just take a span. Deserialize. Wait. Voxel area sterilizer. Sterilizer? Oh, area. Yeah, here. We have the span. It works just the same, good. It's just more flexible. I can remove this. And this too. I'm probably just gonna add this in a scope, right? Well, I mean, I guess I'm doing that here already. Then we have all of this for the array, the other array. Well, the bin actually. That should be fine. Wait, so... No, that's fine. Okay. Technically, I can use a tokenizer. I just realized I just did some deep learning before. So I know what a tokenizer is. It's basically a way to convert. I mean, just instead of a tokenizer, I guess. I just want something that compresses the file. Let me just check GPT. Maybe not there. So, serialization. How can I compress my file even further? Zip, tokenizer, etc. Data format level first. Yeah, that was the plan. For most game save data, I'd recommend this standard. High compression. I mean, I do want real-time stuff though. Slower compression. I guess fast is fine. Then compress each large chunk separately. I mean, yeah, I know. Remove redundancy before compression. Yeah, it is. Let me start this. Start this. Oh! Right, delta position. Because... Right, that makes sense. Oh, that's actually such a good idea. That's so good. Delta encoding. Yep. Wait, so... I mean, that's basically what I'm doing, right? With my voxels. That's what I'm doing. Run length encoding. That's what I kind of... Well, that's what I actually want to do for my voxels at some point. I was thinking about doing this myself, though. Indices instead of repeated strings. Yeah, I was thinking about that kind of stuff. But, I mean, the namespace... Let me think. Because... Yeah, I don't want... Yeah, I mean, Minecraft is 0010. Not really right with this. Bit packing. I mean, I guess I do want a namespace for my blocks, maybe at some point. If your values have a limited range, don't store full ints. But you only have... Wait, example of this. Yeah, I mean, that's what I'm doing. Palette compression. Instead of storing... That's something to do later. Sparse storage. Yeah, I know. Don't tokenize binary data. Oh, okay. I mean, yeah. It's because it doesn't repeat a lot, right? But basically I have my strings. I want to tokenize my strings. Kind of. Maybe. Well, maybe, well. Depends. Well, bad idea actually. Never mind. Forget what I said. Yeah, I just want a namespace system, I guess. So the 2 for each chunk, then save, priority order. Don't serialize unnecessary data. Well, yeah, okay. Yeah. The namespace. Anyways, so we have all of this. Bytes is already a span, so I can remove. And voxel name size is gonna be here. And here we go. Good. So now we're gonna have, instead of the area, right, that's what I was talking about. We're gonna have something like, maybe I can make this a bit more general. Like that's gonna be a structure, maybe, like prefab, like structure schema. Oh, schema. Oh, schema is good. Yeah, schema is good. Or like compact schema, maybe. Compact schema. Yeah, maybe that's good. Oh, compact. Yeah. Yeah, okay, good. So we have this, we are gonna return... I mean, I guess it's not gonna output a voxel area then, but yeah. I should be able to create this when I serialize. Wait, so... Well, yeah. Anyways. Voxels. Yeah, I can probably clean things a little bit. So we have the schema. Out schema. That's what I want. That's what I'm gonna use a lot. And now I want to set all of this. But I guess I'm gonna only set this at the end when it's good. So nb equal nb this. Oh, it's const, isn't it? Yep. Let's go here. Boom. Then we have... I'm so glad I'm finally going to have my schemas. That's gonna be so good. NB blocks per axis. Wait. So wait. ID to voxel name equal std move axis to... No, ID to voxel name. I don't have that. Oh, well. Oh, it's there. I mean, I can have this directly, I suppose. Oh, that's gonna be... I don't like that. I don't like that. Well, no, well. Oh, schema. Okay. Instead, we're gonna have this equal this, so the compiler can optimize. I mean, it can optimize anyways, right? I don't actually need this, but that's fine. And then we have ID to voxel. So let's say this is a reference. Here we go. I'm not sure about doing this, really. Oh, I was thinking, what if we try to update the world, for example? And if it fails, then we don't update it. In that case, it would make sense to have local arrays, but only update this at the end. That would be good. That would be very cool, actually. It would optimize things a little bit. Okay. So let me just do ID to voxel name. Std move at the end. I can do this here too, right? But it's actually not gonna optimize anything. And at the end, I'm gonna have voxels equal std move voxels. So I need an array, local vector. Uint 8. Wait, uint 8? 256. No, that's not uint 8. Wait. How many types am I going to have? I mean, potentially a lot. So yeah, uint 32 is fine. Actually, how many... Yeah, I mean... Yeah, that's fine. That's fine. We can have that, I guess. Yeah, I don't like this too much, but... Let me think about... Let me search something. Well, search. Well, no, never mind. Okay. So we are gonna have the voxel around here. Voxel. And we're just gonna push back. Nothing too difficult. Voxel ID. Oh, that's a voxel proxy. But voxel proxy... Wait. Wait a second. Well, I mean, I guess it's gonna be voxel proxy. Right? I just need the map to convert. I mean, right now, well, no, it's using the singleton. I don't like that. Yeah, I don't like that. I guess I'm gonna keep this. That's fine. And then we have silly move at the end. And it returns true. That's good. And false if it's not correct. Wait. So I have the handle. I have the size and I have the PTR. Right. So that's just going to be a problem, isn't it? Wait. I'm actually not even using this. What the fuck? Bice. Oh no. Okay. I'm glad I noticed. So we have this. What's the constructor? NB block types. And it's a span. This is a span. So from... Well, I'm just gonna create it like this. Unit 8. So with the PTR, and then we have the size. So let me actually buffer span, maybe? Let me call this buffer span. Where we have the size and the pointer. Here we go. And it's not working because it's not... What is this actually? What is PTR? Avoid. No, it's not from the right library. Object bean. Const car. So I need to cast because it's uint, isn't it? Oh, PTR. Actually, no. Wait. Well, I mean, okay, it's because my type is a uint. My bad. So reinterpret casts uint 8. Here we go. Maybe. Oh, pointer. Boom. Const. Please. Okay. Now we have the span and the voxels. I guess. Well, no, it's just here. So we deserialize, we read every time, we push. So I guess I can have a resize instead, resize and initialize. You know, to optimize. With NB voxels. It's not gonna be like that at the end, but that's fine. NB, well, I guess this is outside. Now here we have this. Let's have class type, but it has... What? What do you mean? Oh, right. Wait. So NB voxels is just this. We resize. And then we have... Well, we just have I. Like voxels I equal voxel ID. And this is like very fast. Everything is pre-allocated, kind of. And that's good. That's good, that's good. We are reducing copies as much as we can. Like loading should be pretty fast. So then we assign, and yeah, it should be good. And yeah, I do want to use compact schema to serialize instead. That's something I do want to do. So yeah, I do have the voxel area serializer, but I actually want to bring this function inside the schema. Can I? Maybe, well, maybe inside the serializer class. Maybe that's fine for now. So we have all of this, okay? Okay, we have all of this, good. Let's build. Let's go to... yeah, this should finally be good. So now we should be able to deserialize, right? With the compact schema. Here. Schema. We have a few problems. Like out schema, let's say. Because we might have a in schema. Build. I mean, I do want to test afterwards, right? But I do have a few errors first. Must be trivially destructible. Which one are you talking about? Oh. String name. Oh no. So resize uninitialized, that's why. Resize, let's just resize. Should be good. Or maybe just a reserve and then a push. That way... oh wait, I did have a pushback. Oh no. Well, good enough. Thanks, Godot. So yeah, this is a push. And that way it's gonna... because what's the default constructor for a string name? Like, I guess it's initializing a bunch of stuff. Is it? Maybe not. Like, default constructor, nothing. Well, nothing other than the default things, right? I mean, I do want to initialize it. Okay, that's fine. Anyways. So now, let's build. And we have to compare the input to the output in area to the schema. So we're gonna loop in area. Space. Oh, right. Wow. That's fine. Well, first I want to check if this case require equality. Let's have this between out schema points this and yeah, it compiled good. This, let me actually run the unit test again. Okay, it doesn't work anymore. Couldn't map PC to read 47. So my previous function doesn't work anymore because of my modifications. So I'm gonna have to fix that. 47. What? No, wait. Chunk serializer. Read. Okay, that's here. Dump, okay. Chunk serializer 47. Let me check here. Read. What? Bytes. Because bytes is not valid, it should be valid. Is it initialized? It is. Actually, do I have... Wait, NB bytes, NB bits. I don't have NB bytes, so I can remove that. Right? Yeah. And yeah, the rest should be initialized. Yeah. Okay. What a calm music. Well, we're gonna debug things afterwards, right? I just want to write my text first, I guess. So require equal. Well, equality between this, a vector 3i, and the area gets NB blocks per axis. Here we go. That should be equal. And if it is equal, then we continue. So next is going to... We want edit to voxel name, naturally. MG, hi, Rupert, hello. Winning? Are you winning, son? Yeah, I am. I am, daddy. So... I guess it's gonna be very simple. I guess I don't even need to check the dimensions anymore. Like, I can just use I equals 0. I is less than... Can I? No, I can't. No, I can't because I still have to sample the area. Do I? Oh no, not if I... Oh, I have an idea. Well, I had one earlier too, but this one is good. This time is good. So in serialize, as I mentioned earlier, I have to get my map and a few things, right? And what I was thinking about is... I don't need that. I want to serialize the area into... Well, I want to convert the area into my compact schema. That would be amazing. Because that's what I need anyways. So let me try making a function for that. Like voxel area to compact schema. And we are gonna have voxel area. So yeah, we're still on the serialization, Robert. We are still trying to not save anymore, but actually load this time. But at the same time, I made this little struct that is going to be very useful for a bunch of things. We're going to reuse it everywhere, I feel like. We might have what's the opposite of compact? A sparse schema. Hey, good day, Mr. Proxy. It's a night. It's night, but thanks. Have a nice week. Thanks. A week? Are you leaving? Never coming back? I mean, thanks, I appreciate you too. So we have the area. Yeah, the problem with the area is that we need a reference to the chunk space. And the chunk space is, you know, not independent enough. I like when things are independent, without any good objects, basically. Guys, today I threw away my hat, which I was wearing since like 2019. Oh, whoa, what hat was it? Was there something weird written on it? Wait, 2019, what was that? Black baseball hat. I see. Voxel area to compact schema. Actually, let me bring this here. So now we have the compact schema. Ooh. Oh, it's schema. What was it? It was COVID, yeah, Mr. Streamer. Oh. So that's why you bought a hat. You were like, I'm gonna stay inside the whole year. Let's buy a hat. No, I'm kidding. I don't know how was COVID for you. To prevent COVID? No. To prevent COVID? No. I wasn't thinking about that. But, yeah. Wow. Anyways. Okay. So we have the area and we want to convert it to a compact schema. So the first one is going to be pretty simple. NB blocks per axis is going to be area gets this. Okay. And then we have the get voxel type map. Right? I was going to say pretty important, but maybe not. Well, I mean, I guess that means there's going to be a conversion anyways. Oh, I don't like that. Pack array. Yeah, I'm not sure about that. I mean, I'm gonna have allocations anyways. And then we have get compressed voxels. Yeah, I mean, this one is kind of necessary. Get compressed voxels. Wait. What does it use? The size and the get. Well, I mean, actually, I do need this. Well, okay, never mind. I can't just convert like that. Well, technically, I could. Is it moral to like COVID years, even though lots of people died? I mean, I think you can see things as, you know, you had like in your life, in your own life, right? We're talking about personal life. There are like some cons, right? But there are also some pros, I guess. Like life can be a bit easier, like with remote, for example, that kind of stuff. I think that's fair to say. That you have like positives and negatives, but you know, of course, you have a pretty big negatives, right? But yeah, morality scaling stream when. We don't need that. Just kidding. I can stream my thoughts directly into you. Just kidding. Actually, can I? No, I can't. It's a hash map, right? So it's not going to be contiguous. Like if I do point keys, like point values, yeah, I don't have that. Oh. Oh. I have an idea. Guys, feel free to ask Mr. Streamerity questions. He's gladly going to answer them. Sure. I mean, if you want. I guess my limit would be, you know, well, politics, I won't talk about people. And I won't talk really about actual, like, left-right stuff. I don't really want to, you know, talk about that kind of stuff. Because, I mean, you know, that's not my... what my stream is about, right? Religion... I mean, basically, I'm just going to... You can ask whatever question you want. I'm just going to give pretty general questions. If I don't want to answer. No, small-scale questions, please. Yeah. I'm just gonna be like, politics. I see in the future a good government that is good for everyone, that is good enough, right? Oh no, that might make some people angry, right? Like how do you call that? Anarchists, right? OMG, a good government, right? Yeah, I promise a good government for for everyone. You know, just talking like a politician. Me president, I will end suffering and and become king. But that's a detail. You don't have to talk about that. Government people will be pissed. Complex schema. I mean, technically I can have this. So what I was thinking about was right now, when I'm converting stuff, where is it? Right, get compressed voxels. There, I have the map, right? And I think I still do want the map to some degree. But, you know. Well, I do want the map, but we said map value. Yeah, this is only using local ID. So local ID is actually, I'm just gonna split my stuff. I'm just going to split my stuff. I'm just going to have, so we have voxel map value, right? Instead of this, I'm gonna have something like a hash map to an integer, and then a local vector. And I think that's gonna be good because this doesn't, like, this is nothing. Like, what is that, right? Can I actually resize a hash map? Reserve? Oh, I can reserve it. Can I allocate it? I can do a new allocation. Oh! No, I can't. Wait. Can I have a custom allocator? I should be able to, right? Comparator. Hasher. What about allocator? Allocate on demand. Memory alloc... A hash map. Godot C++ custom allocator. Okay, it doesn't support. Oh. Flats, nodes. Oh, so, okay. Nice. Very fast. Drop in replacement. Oh. Parallel hash map. Fast and memory friendly. Parallel. Oh. Anyways, I don't need this. So basically it doesn't support custom allocators. That's fine because I can always change it if I want. I can always modify the engine if I need to after that. So what was I doing? Right, I need my function. So I need to modify this. So I said this was going to be... Wait, why is it not good anymore? A hash map. Huh? Voxel map value. Incompatible. False voxel area. A hash map. Uint. Uint. I don't get it. Oh, it's because I modified it and didn't save, maybe. Did I? I have no idea. Never mind. Well, that's good. Okay. So let's go back here. And we're gonna have the... well, we're gonna have a vector. Local vector of string names. That's gonna be block types. Like out block types. And then we are gonna have the map. That's gonna be from an integer to this. Well, yeah. From integer to an index. Uint 32 to the local index. I mean, well. Map. It's like two local. Map to local. Voxels. Out map to local voxels. Maybe. So now we have all of this. So I can have... because technically, even if I split my stuff, even if I split that into different types, like you would say that local vector and hash map, that means we need two different allocations, right? So it's going to be slower. But technically we can, since we know, actually we don't know local vector. Oh, right. Never mind, actually I guess we don't know. Good enough. That's fine. So, anyways, let's do this. Oh. I'm gonna remove this. Out block types. So I'm gonna push back for this. The name. Oh, no, only if it's not there. Well, okay, I already have that actually. So, out. Does it have that? Insert. It's not returning, is it? Insert iterator. Yeah, it's not. Okay, so insert... well. This. Has. If it doesn't have that, then we insert new with, well, from the ID of the voxel to the new value, which is, well, local ID, so from 0, right? So I can remove, well, this. Now I have the out block types. Well, like this, good. And I can also remove that technically. Good. Maybe. So I guess we're gonna have some more allocations. Yeah, I don't actually like that. How much do I want to optimize the allocations for this? I mean, it shouldn't be a problem. Should it? I don't know. It's not as if I can reuse the buffers the same way as with I mean, technically, wait. Well, that just means I need copies. I'm not sure. I think like I did something bad. Do I want this and this? I mean, it's not really important. Let's do... Maybe it was fine before. That's fine. That's fine. Because we have to push anyways. We might know the type. Well, we might know... Well. Okay, anyways. Let's keep this. Yeah, let's just keep this. So I do have my function. Let's do this. Well, this. Voxel map value. Here we go. Like that. So we have the area. Then we are gonna have this. Resize. Wait, what is writer? I'm not writing. Back. Wait. Wait, what? Output? Oh, yeah, because it's there. Wait, if I resize, that means this is not gonna be valid anymore, is it? Oh, no. Oh! No, never mind, I get it. No, okay, I get it. That's fine. Oh, that's fine. That should be alright. I hope. Yeah, that's fine, that's fine, that's fine. So, we're gonna have this. I guess if I know it ahead of time, I can resolve everything ahead of time. So this. Local map, so we have the byte. Wait, we have the byte? Right, wait. Right, I can prevent a copy like that. I mean, I guess I think I don't want to optimize too much. Let's remove this. That's fine. I'm gonna have this at some point, probably, but that's fine for now. I need to focus on what works right now. So we're gonna have win32 x, well, z equals 0. Z is less, well, actually, this. Oh, well, area point min equals 0. Wait, what am I doing? This point x point z. Z is less or equal to the max with z and z++. Can I just go in? Inclusive. Just a note to myself. So we have the same. Then we have y. Y. I didn't miss it. And we have x. Caliber. Ooh. And now we can just check everything. You can check if in area, so we have the space. Yeah, actually, I should make a function like getBlock, something like that. Space. Well, technically, I can just do that, like voxel. Get voxel. Wait, do I even have? I do. Wait, where was it? Chunk. Store rate. No, well, space. Get voxel. Oh, I have to cast. I have to cast. So something like this. Maybe. In area. I mean, I already have the space. I can just use that, I guess. So, space. Get voxel from the coordinates. Vector 3i. X, Y, Z. And we are gonna check if this is... Well, this is a voxel proxy, right? Proxy. Equal this. Yeah, I mean, I guess my problem right now is that I'm using a singleton for my voxel proxies. I should have like a reference to the actual proxy I want. That's my main problem. Yep. So proxy. I want to check if the ID is equal. Well, it's not going to be equal, actually. I want to check if, not the ID, but the name. Get name. Because it's string names, right? So it should be pretty fast to compare to. So we're going to do that. We're going to compare the names with the schema's name. Because the indices are going to be different. The IDs are going to be different because this is compact, right? That's the point. So ID to voxel name. Wait. So we have, let me just have uint32i equals 0. Oh, actually, I should be able to have this here. Maybe not. I can. Wait, I can. But I can't do that. I. Oh, because I is already... No, I'm declaring it. I'm declaring I here. Well, good enough. So then we have I++. And we're gonna do... So we have the schema. We have the voxels. We're gonna get I. We're gonna get I. And we're gonna get the name from this. Pretty efficient, isn't it? And the name should be equal. And now we can build. And we can actually just run this with tests. So... No. Oh no. That's bad. Quick, quick, quick. Apply. Good. So now we should run the tests. Please. Yep, yep, yep. Okay, let's run the tests. Oh, right. Wait, is he... Oh! Well, technically. Yeah, I mean, that makes sense. My bad. I'm not gonna modify this right now because I want the breakpoints and stuff. I want the debugger to debug. Crazy, I know. Copy paste. Why is it modifying this? Recompiling this? Oh, because I'm including the serializer inside. That's why. Yeah, I mean, the music from Hades is like pretty nice. Hmm. It's taking a while, but finally it just finished. After how long? Wait, actually, never mind. Actually, never mind. I feel like it's because it has to recompile everything in the header, right? In the headers. Because I don't have a point CPP for... How was it called? Like, the good thing with... Wait, where is it? Details? I can't find it. Gameplay? No. Generation? No. Inventory? Rendering? No. Where is it? Oh, it's head only. Yeah, it's not C++. It's not... It's gonna be with the C++ files. Yes, so right there. What I was saying is that the really cool thing with this library, message pack, is that everything is in the header files, so we can just copy and this is it. But the really bad thing is that it's going to be pretty long to compile, because it's not going to make, you know, like build the C++ stuff. The C++ file, like the object files. Actually, well, no, yeah. So this one, what's the problem with this? Oop. Full stack. Read. Oh no. Yeah, bytes is 0. Okay, good. That's good. That's good. I like that. So if it's null, that means this is null. So let's go here. And do we have bytes span? So is this null? Is there something here? That's gonna be my question. Optimize the way. Ooh. So this serializer, there's nothing there. What about here? Blocks. There is something here. Wait. Bytes. No, bytes is 0. Oh. Wait, what? Serialize is not serializing? Oh, it's in storage? Wait. No, never mind. So... yeah, that's the first thing. So out bytes. I'm actually not doing anything. Well, I do have to assign this at some point, right? So let's just restart. And we're gonna have std move from the serializer to bytes, to out bytes. Now it should be good. Now it's gonna be valid and it's gonna be nice. Oh. Okay. Build done. And it's crashing again. No! So this time, why is it crashing? Area serializer. So at least this is this passing? Well, I can't see actually the console. Well, it's probably here. Yeah, it's good. It seems to be good. Look at that. There's no error here. So that's good. Probably. So this one has a little problem with accessing, is this now? Singleton. Oh. Oh no. Get name. Oh, I mean, yeah, it doesn't exist. Yeah, my bad. Wait. Oh no, that's bad. Oh, that's so bad. Because I'm trying to access the database. That's what I was talking about. I shouldn't have this database. Because now I can't really do stuff. I mean, technically I could just add things there, right? In my unit test, but well, maybe I'm gonna have to for now. But then I'm going to push back the thing again and again, I feel like. I'm not sure. I don't know. I don't know. I should put that in the space and remove the operator overload, I feel like. That's a shame, but that's a shame because it made it pretty simple to check things, but yeah. Because, yeah, it doesn't exist, right? So I guess instead of a crash... Well... Because I also have... Get singleton and now, right? Well... Yeah, I'm gonna have to change this. I mean, this is just the voxel database. Make voxel type. I mean, I guess that... Yeah, what is this? Well... Never mind. I know what it is. Singleton. Yeah, I don't want this. I don't know. A resource I could also have. A resource could be alright. I could make a resource. Man, that looks complicated. Yeah. Well, basically, it's because I made a singleton. It's my fault. Like, you know how they say that singletons are bad patterns and stuff? Well, the thing is, right now, thanks to my singleton, I can basically do something like... like this. Like right now, I have like, for example, voxel. Like, I have no idea. Well, actually, maybe I don't have an example. Oh, wait. Something... Wait. Well, I can have something like this, for example. Right? I can have something like this without any... Like, if I want to set a block, I can just do that. Right? And that's like pretty good. But, like, for example, bedrock, I can just like set this value directly, right? So it's like pretty convenient. And there's also a few other things. Like when I check, for example, for the visual, face builder, I guess. I check if this is opaque, right? If the block is opaque. And I can just use this operator, right? That is like basically accessing the singleton. Is it? No, wait. Blocks. Yeah, it is, right. Because this is a voxel proxy. And voxel proxy is actually an integer. So that makes it pretty convenient. But yeah, I'm gonna have to change that, I guess. I'm gonna just put this in the... put a reference of that in the space, probably. I think that's the thing to do. Because there's not a lot of things in the space, in the first place. Like chunk space. I don't have a lot of data. I have like a lot of functions. Well, I have some stuff I should remove, honestly, but that's fine. Well, remove. Well, maybe. So, neighbor chunk. Well, we have all of those things. Yeah, that's a node too. I'm not sure I should have this, but anyways, so louder. Okay. Anyways, so we have voxel database. I might want a reference to that, and I guess there's just... Do I have a constructor or something? I do, and it's checking whether it's a singleton or not. That's a problem. Ah! I can't instantiate multiple of this. Multiple instances of this. Which is kind of fine, in a way. String name ID. That's bad. Right. I was planning to do that anyways. I just don't want to overcomplicate things for now. So I might just do something crazy. Are you ready? Let's go to the unit test for now. And we're just gonna do initialize dummy. We're just gonna register to the voxel database. Like voxel DB. Register voxel type. Like get singleton actually. Get singleton. Register voxel type. Because I don't want to modify things too much right now because I'm working on the serialization. That's what's important. So I'm gonna register this new type. Maybe, wait. Reference to voxel type. Oh, well. Voxel type. Type. It doesn't actually matter what this is. I just need the name. Name equal this. And that's gonna be all right. So like this, and we register the voxel type. Oh, it's a reference. Oh, because it's a resource. Oh no. Ew. So I'm gonna do instantiate. And this. Here we go. Here we go, here we go. So I might just want to, yeah, let's do remove voxel db and have local one, like singleton. And have local one. So forbidden. Well, let's say it's like not generated. Get. Oh, that's a name I want. Well, that's fine. So then we have the air, grass, stone, diamond, air, grass, stone, diamond. Here we go, and we have the names, and it should be good. You just get there. Yeah, that's like this static thing. That's like kind of ugly too. But that's fine, maybe. For now. For now, that's fine. Oh no. What's that? Is it because I don't have enough memory on my disk? No, that's fine. Let's, I guess maybe because I saved. Let's start this. And let's see if it works, because I should be able to register voxel types dynamically. Push back, and this. Yep. Should be good. Wait, I just realized, but how am I accessing this again? It's an integer, right? Yeah. Well, get voxel type. Yeah, I'm just accessing the array. That's fine. Oh, I still have to fix this. Right, after this. A hash map key not found. Oh. Voxel DB, it's not anything. Wait, do I have to register it? Why is it not valid? Wait. Wait. Yeah, why is it not good? Oh. Why is it not good? Get. Am I... oh, because the module is not initialized. Is that why? Oh. Oh, so I can basically create my singleton here. So actually that's fine. Kind of, for now. Like I can have... Wait. Let's do... this. I mean, the singleton is valid though. Wait. Static get. Oh. Because I'm not loading... Oh, right. Wait, I have to call this. Wait. I have to load this. I guess I do. I guess I don't have the dictionary. So technically I don't even need all of this, right? I can just do some padding. It doesn't have to be this. That's fine. That's fine, we're just gonna do that. We're just gonna register the types. That's it. I'm gonna cancel. And I just want to 50. Let's actually 25. And we're gonna push this. Plus equal 4. So 100, like, well. What was it? It was 100, right? Yeah. Plus equal 4. And we can have this with a loop for j equals 0, j less than 4, j plus plus. Oop. And this is I plus j. Here we go. So I'm setting multiple blocks to be of the same type, because otherwise it wouldn't be right. I'm doing that so I can test if this is compressing correctly. I forgot about that. Shit. You know what? Well, next time. Next time. For sure. Next time for sure. I mean, I was just talking about how these are a lot of includes, right? This message pack. But if I include message pack only in the serializer file, then it's basically going to compile with the serializer file. Insufficient bytes. Oh, okay, message pack. It has to do with message pack this time. Deserialize. Unpack. What? Oh, it's trying to unpack more than... Huh. Okay, so it managed to get here. It managed to get here. It's not that bad. And it's the deserialize. It's not even the serialize. Okay. So we managed to... Yeah, what are the values actually? I did to voxel. What is that? Oh no. Wait. No, that's not good. Is it? Version. So version, what is the version? I can't even see it. What is that? What do you mean undefined? Wait. What do you mean undefined? It's there. Okay. So we unpack. Did I forget to unpack? So I'm unpacking here. And it's saying that there are no more length 17. Huh. Offset 17. 17? What about this? No, never mind. Yeah, so nothing here makes sense. So I think that's the problem. Unable to read memory. Oh, now it is. Able to. Kind of. No, it's not. So I might want to debug this. Yeah, we probably want that. What about this? No, it's not gonna be good. Yeah, nah. Okay. Let me check the input then. Bytes. I mean, it's just bytes, right? It's not as if I'm gonna be able to know a lot of things from the byte. So we need to put a breakpoint there. Maybe. We have... Let me just check str. That's fine. And the serialize. Pack str, pack str body. So pack a version. Uint 32. Can I just pack uint32. I can. Maybe that's what was kind of wrong. I'm not sure. No, that's fine. Yeah, that's fine. So we pack this. Then we pack an array of strings. So what do? We unpack the version. Then we unpack well, we unpack the array. In the array, we have the size, we have the pointer. So voxel name size 1. What the fuck? What? Wait, what? What do you mean 1? What do you mean 1? But it's optimized too. How can I remove the optimization for the tests? Like, tests shouldn't be optimized out, I feel like. Or should they? Actually, it depends. I guess I want to output the version. Anyways, so... yeah, I don't know. Insufficient bytes. I understand that. Like 17 isn't a lot. So even though we have some problems, I feel like the binary isn't serialized in the first place. Because this is bullshit. Well. Yeah, I mean, this is definitely not working. Local voxel map. Let me just put a breakpoint here. And restart. And see if things are serialized properly or not. Shit, integrals. Shit. No, that's good. Just in time, just this time. Please, just in time. Yeah, please. Should be good. Maybe. No, it wasn't. It wasn't in time. Okay, so here we go. Version. We can't really see it, but okay. Then we have local voxel map. What the fuck? It just continued. Is it taking that much time? What? What the fuck? Why was this so long? $12,713. It's not supposed to be that long. Is it? Except if there are some errors. Optimized out. Shit. Yeah, I mean... oh, wait, the serializer is... wait, where's the serializer? It's in core, right? Right. So I can remove the optimization. Oh, right. My bad, my bad. Yeah, let's do that. We have SC sub. And I'm gonna do this. And what? Well, and inside I have the debug. So what was it? Collisions? Voxel collisions. SC sub. Debug enabled. Yep. Something like this. And now can I like restart or recompile? Or do something? No, I have to rebuild the projects. And I'm gonna take the opportunity to update the types. There we go. Good, 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 good. I guess for the donut, it's always going to be positive, but for something like an infinite world, it's gonna be negative, potentially, if it's like infinite. So that's why it's integers and not uints, not unsigned. Okay. Here we go. 19 calls. Good to me. Let's close this. Sorry for the flashbang. What can I have? Other tests. I want other tests. Other kind of tests. Well, I mean, I do want to modify the database, right? The voxel database. And not making it a singleton anymore. But yeah. We're gonna see. We're gonna see how it goes. And that means we can, if we make it a resource, that means we can register things a lot more easily too. Because that means we can access it from the editor. So we don't need those abstractions, well, those kind of classes that are just accessing the singleton that I've been using. Okay, good. Let's run. And it should please rebuild the module, the core module. So yeah, okay. Good. It's rebuilding serialization at least. Wait, no, that's the test. It's building the test. Yeah, no, it's building everything. Good, 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 good. I like that. I like that. Ignoring unknown option. Overriding this with this. Oh. Because I'm giving two arguments. Okay. Okay, here we go. So, now version. Yes! We can debug that. So version. Good, good, good. Maybe I want to add more checks. So wait, is this valid? Size 1. Value. Padding 0. There's a problem. Let's restart. And let's go in. So for all of this, we try to get the name. Well, that's a problem. So if it doesn't have this, voxel ID, XYZ, we do the plus plus. I don't get it. Min, max. Let's go in. Local ID. So voxel is 0. That's fine. So we add this. This is padding 0. We continue. ID++. We continue. This one is 0. And X is 2. X is 2. What? Oh, right. No, this is fine. So we continue. Now we have X equal 5. So it should be a different voxel, but it's 0 for some reason. So let me just get here. Oh. Well, yeah. Well, so dummy. Storage. 1, 2, 3, 4, 5, 6. Oh no. Oh, the IDs are wrong. Well, they're good but wrong. Because of that. The amount of voxels. Oh, right, I forgot about that. Oh, so I don't actually need this. Never mind. Yeah, I don't actually need this. J. Right, I forgot. So we have the size. -1, +1. So it isn't 0, I guess. What? Yeah, it's not supposed to be 0. How is it? Wait, what? Storage block. Wait. Wait a second. I mean, I guess I modified it, but... Please. When I serialize that, we have the space. We have one chunk. That's good. And inside we have the... Oh, hey, sorry. Oh, wait, I'm just inspecting this. I actually have a window that's hiding the chat a little bit. So, sorry, I can't really see right now, but I see you. Ho ho. Mukatte kuru ka. Is our... Oh, it's out of stock. Oh no. Storage. Wait, what? Wait, storage is... There's nothing there. I love your sound. Ho ho. 向かってくるのか。このデュオに近づいて向かってくるのか。近づかなきゃ。てめえをぶちのめせないんでな。ほうほう。では、十分近づくがよい。陽太郎。ディオ。てってってってるってってってる。Add one more. Butler. Yes, sir. Butler. Butler. かかってこいよ。Thanks. I appreciate. I need that. I needed that. So in area, what time is it? It's 2 a.m. When? How did it happen? Are you done with save files or going on? I'm trying to debug. So basically, I've kind of finished what I wanted to do. But I have a unit test that basically verifies if this is working or not. And this is not working. So I'm trying to debug that. At least now I'm in the debug phase. So... voxel area. So we have the space. Wait, initialize dummy. Oh. Oh! It's because I'm never setting... Oh. Okay, I'm stupid. Okay, I get it. I get it. Okay, I get it. So, set NV cubes, we have all of this. And that's why, because it's initializing everything to uninitialize, basically, like, somewhere, like there, right? But I need to set the blocks. So I have my space. I have the map. I guess I do. What I need to do is... Where was that again? Storage, okay. So what I need to do is, after creating the chunk, well, in the space, I guess, I'm gonna do space, set voxel. Wait, I have a get voxel. Do I have a set voxel? I do. So now I can have the coordinates and the proxy. Okay, let's check this. Map. Oh. Oh, what was that? So NV voxels. Yeah, this is bullshit. NV voxels will be something like default chunk size. I mean, like this. So now we can, well, yeah, let's create that first. So we have all of this, then we create this. Debugging again at 2 AM. You should probably sleep, yeah. I'm actually scripting my door. Good luck. Yeah, wait. Scripting your door? You're talking, wait, is it about... Wait. Wait. Never mind. Wait. Never mind. Yeah, never mind. Good luck. Good luck. So set voxel. Right, so I have my NV voxels, yeah. So I have the default size. And I'm gonna do... Oh. Default... Let's do something a bit more simple. Default size... Now we have the default size, we have this point x times point y times point z. Good. We initialize. And now we can do our loop. So we are going to have a loop that's going to initialize everything. I mean, actually, I guess I can just set everything inside the chunk. Right? Because I have this chunk. I should be able to cast it even. But no, let's just make well, let's just do that. So we're gonna have the set voxel. This is gonna be from 0. From 0. Wait, meaning it's 1. Well, I mean, I guess that's fine. Yeah, that's gonna be fine. So 0. To... I don't need I. 2 default... Well, chunk size, wait. Default size. Boom, like that. Now we can set voxel. We're gonna have vector free I with x, y, z. And the voxel proxy is gonna be... What is it gonna be? So you have the storage. Right, and we can just... Oh, so it's actually I. So I actually need I. My bad. I++. Storage, point blocks, I. And now it should be good. Yeah, it was just missing. I just forgot about assigning the blocks. So it's not even a problem from my serialization. It's a problem from my test. Good enough. Also, that means I only have one file to compile, I think. Wait, let me check if... serializer. Yeah, I'm not importing what I don't have to. Good. Good, good, good. I'm not importing message packs, so it's pretty fast. Linking. Oh, get. Okay, now it's a bit different. Good. Good, and it's not a problem about reading the message pack either. That's nice. That's good. That's great. That's amazing. 5, 7, 14. Oh. Wait, 5? 7, 14. So this is in the test. Oh, never mind. It's when I tried to create it. Wait, what? Hi. Oh, because it's equal. Oh, no. My bad. My bad. Let's remove the equal. And now it's gonna be fine. Hopefully. Hopefully it's good. Wait, it was 100, right? So I guess I'm not gonna have repetitions. Wait. Well, actually, I guess I am. Just a little bit, but yeah. 1000, yeah. Yeah, never mind. Should be good. Brr. Linking. I'm gonna add a to-do to my readme. Well, next time, I guess. So, local ID. So now I can go in. Well, let's go out, I guess. We're gonna have the elements or not. Well, so let's do. Wait, how can I access this again? Elements. This. You know what? Never mind. Oh, elements. Right. So we have this elements. Key value. Let's do. Can I have like 10? No, that's bullshit. Yeah, bad idea. Okay, that's fine. Let's continue. So we write the version 0. We write the size of the array. I don't even know what it is. Size 1. Wait, size is. Oh, never mind. Size is 1. Wait, size is 1? Again? I hate it. Okay, let's finish. And crash at the same place. So something is wrong. I don't know. I mean, I know, but it has to do with my initialization. That's the problem. Or maybe it's just returning this. Because it was 0, right? Am I actually registering this? Register chunk. It should be registered. Yeah, it should be good. Okay, let's try again. And this time we're gonna go... Where are we gonna go? Can I do that? Well, yeah, I should. I should be able to. And... try add, initialize, serializer, get voxel. Okay, good. So here, boom. Try add chunk. Good. It's null. So I instantiate it. I set the coordinates. I register. So it goes here. Cube chunk space. We go here. We push. I'm a drunk. Oh no. Push back. Nothing. So this is 1, 0, 1, 0. Wait, 0, 1, 0. Wait, what? Oh no, 0, 1, 0. How is it possible? Chunk card. Oh no. Oh, wait. Oh, right. That's why it's not working. Let's do this. Yeah. I want to make my space a bit better. With less dependencies. Because I have a lot right now. Okay, here we go. Get voxel. Get position. So this is 0, 0, 0. And it wasn't finding the chunk before, so it was returning this. Which is a problem. I should have like an error or something. Error fail. Maybe. So let's continue. Let's not continue. Wait, what? Why is it doing this? Local cards 111. Size 0. Storage. Wait, really? Get voxel. I tried to set it though, but that's a good start. So right now, I had this problem when it's returning voxel. Well, something I forgot. This, right? And I want to crash maybe. When I crash now. I mean, I guess crash now. It's fine. Yeah, that's fine. Good, good, good. Let's restart. Because I don't want this kind of error, right? Would be kind of bad. That voxel should be the same. If it doesn't find, then I crash. Yeah, I was thinking about returning like a Boolean, but nah. It's starting to be late. I do have to go a bit early today. Because, I mean, I haven't slept a lot the previous days. Oh. I mean, yeah, same problem. Right? It's because blocks is nothing. But that means, let's restart. That means my set is not working. Like this. There is set voxel, right? And if it, well, if it was working, then it would just work, right? Oh no, it's storage blocks. Never mind, wait, storage blocks. Wait, why is it working then? Wait, that doesn't make sense. Initialize dummy. Storage. Resize and initialized. Wait, this is good. So yeah, storage blocks. This is valid. Wait, why is it crashing? Oh, right, inside the chunk. Yeah, never mind. So, inside the chunk. I mean, let's just try again. And we should just go inside. Coordinates. 0, 0. Get pointer. It's not crashing. So there's a cast. We set the local block. What? I mean, I guess. I guess. Oh, wait, is it that I have no... No, it should be good. Okay, so we go there. We go in. Not here. But... here. Not here, but here. Perfect. Now we have all of this. We have the chunk. We set the local block. So we go... Oh. It's size 0. How can you set a size if it's not initialized in the first place? That's bad, isn't it? Wait, what am I doing with the... Wait. How am I doing with the generation? Generation? Like generator? Maybe not. Voxel generation. This. This. There should be a resize at the top. Or something like that. Maybe not at the top anymore. Generate chunk. Generate cube chunk. Resize and initialize. That's it. That's what I want. That's what I need. So here. And we're gonna have... I mean, yeah, why is it not crashing when I have output? There's no error either. That doesn't make any sense. Set local block. I go there. And it's not crashing, it's just trying to set, but it's not good. Error fail index. Oh, okay, now I see it. Oh, never mind, okay. Okay, I see it. So, my bad. I mean, let's just do something like this. Cast. Like, let's just do that, really. And we have this, we have default size, please. But it compiled too fast. Do I have NB voxels? I do. Here we go. So now it should be resized and good and fine. I mean, I guess it wasn't working because I wasn't generating the chunk properly. Maybe I need to add some utilities or something, I don't know. Here we go. Insufficient bytes. Okay. Good. So I fixed a few problems. But in the end, I still have that because it doesn't have anything to do with the sterilization. It's just that the bytes are going to have a better... Right. It's going to be a bit better. So, out schema. No. Deserialize. Unpack. Where is it? Here. Require equal. No. It's for... Wait. No, never mind. It's the deserialize. So we go in. And the first... Wait, the first one is actually not working. Wait, the first one is not working? Wait. That's the first value. It's the first value and it's not good. Unpack. So bytes, we have all of that. PTR. Oh! It wasn't initialized. My bad. Yeah, I mean, I know why I wasn't initializing it. Because it's supposed to modify offsets, right? Because it's a reference. So in my head, when you have a reference like that, that's modified, it's what? It's like an output. So I wasn't thinking about initializing it. But now it's gonna be a lot better, right? Like the offset is, I mean, yeah, of course it's like outside of the bytes array. That's why it was crashing at different places too. Okay. That's gonna be promising. I probably won't... Shit. I wanted a breakpoint, but I guess I'm having it. So, where is this one? Okay, it's here again. Voxels. So, is this good? This is good. Okay, we managed to retrieve this. Wait, so this is good? What about ID to voxel? 83... I mean, I'm not sure about all of that. But it seems kind of correct, right? It seems like something. Good. So then we try to unpack. And... offset. It's not good. Why is it not good? Wait, what? Offsets. We have the size. Wait, what's the error? Insufficient bytes at memory location. What? How is it possible? Is it because it's trying to read all of this? I don't even have the size. Wait. $1092. That's what I'm trying to read. Yeah, wait. I don't get it. Is the size of the bin wrong? Let me check something. Unpack. So bytes. 1947. 1947. Let me actually note it in my readme, maybe. Bytes 1947. Then we have offset 991. And I want to check. Well, yeah, I think it's... I don't have enough space. Because then we have the size of this. Well, it's supposed to be this, right? So like there's the size, there's the pointer that I can't have right now. And this is basically the size of all of it. Well, no, it's not. Actually, it's a bit different. NG voxels 1092. So if we were adding this, there would be a problem. But we're not just adding this, right? We're trying to compress it. Well, we compressed it. So that should be fine. Maybe I have an idea. Sterilize. Where is it? It's there. Sterilize. Pack bin. Get NV blocks. That is the problem. Because this is the size of bytes, right? But we don't want the amount of blocks, because then, of course, it's not going to be enough. Instead, we want this. We get the bytes, and then we have the size in bytes. And resize. I mean, I guess I can do that. Let's just restart. So bytes, so then we use this, and yeah, it should be alright. Should be alright. Because yeah, this value should be the same as this one, right? So that's good. Okay, good. Okay, we're debugging pretty fast. It's just compiling a bit slowly, but we're debugging pretty fast. I'm glad I split my code into multiple modules, because this would take even more time. I feel like, if I didn't. 30 seconds every time. Yeah, that's gonna take... Oh! Got 0! Wait. So it worked. It worked. Did it? If we can finish on this, that would be so good. Okay, let's check this. It passed! It worked! Yes! We can save anything. Well, our voxels now. This is so good. I love it. Oh my god. Oh, this is so good. Instances were leaked. Right. So, how about this? I know. I'm just gonna go there and do... So for example, I have this one, right? Menu. So I'm gonna try to... Well, I'm gonna just mem delete it. And that should be good. Yeah, it should be alright. Why am I using a menu? Is that the only place? I guess. I guess so. So the child should be removed too, right? When I delete this. Good. That's so good. So I'm gonna be able to push. Let me just run this again to verify that we remove the leaks. We still have some leaks. I'm not sure where it is. Verbose. Can I actually do that? No. What about verbose? I'm actually already doing that. So I don't know. I don't know how to do that. Because this is working well. So I'm not sure where the leaks are. Oh, maybe from the previous... I mean, I guess I have multiple, like, different ideas. maybe not. Oh, from the voxel database, maybe. Oh. Menu. Not even here. I mean, that's fine. I don't care about leaks right now. Well, I'm gonna at some point, but yeah, that's fine. So, I mean, we have so many people in the, well, maybe not in the chat, but watching the stream today. I kind of want to continue, but it's like 2 a.m., well, 3 a.m. almost. Okay, so we have the copy, well, we have the save, we have the load. Oh, that's so good. I love this so much. Okay. So can I compute the time? Yeah, there was something that was taking a lot of time. Can I try to... I mean, I can just run it, actually. Let me just run it. It's like almost instant, right? That's fine. I can save and load in pretty fast. Pretty fast. Godot, C++, unit test, measure time. I guess I can do that myself. SC chrono. Or this. I can use that. I'm gonna use Godot. And I wanted, like, I have a message right there. Let's put something else here. And this is gonna be time. And we're gonna have, wait, plus, right, is this. Time plus this. And this is gonna be float. Two floats. Oh, wait. No. Wait. No. I mean, I guess I can just directly have the float here. Okay, let me just measure. We're gonna have time. Wow. Time gets singleton. So time. Core OS time. Core OS time. So we have this, we have get singleton. We get this, we have the get ticks. Microseconds. Like this. Like this, like this. US maybe. Microseconds. Well, start. Then we have end. And we just display ends minus start. And to float. No, I actually want to keep integrals. I want to keep this in microseconds to make sure it's accurate. Okay, let's start. Microseconds. Here we go. Okay, here we go. Then at the end we have the message. I mean, I don't actually have to build this, like to run this, I mean. I can just run from here without the debugger. Thinking. Done. Well, I mean, I guess well, it's not gonna do anything. Boom! Let's try here. Microseconds. 1K. So 1K is basically 1 millisecond? Wait, is it 1 millisecond? Oh no! Wait, that's really bad. I mean, I guess the thing is, I can have this in parallel. I can run this in parallel. I mean, also something else that I want is, I want to know the amount of bytes. So we are gonna have this. Bytes. Well. Let's have this. Let's do plus equal. NV voxels. That's gonna be this. And then we have the memory. So bytes. That's gonna be bytes point size. And should be nice, should be good. Oh no, that's not good, that's not good. Okay, now it is. Too late. I hope not. That's fine. That's fine either case. I just want to know the performance so I can optimize it in the future, right? Like both in time but also in memory. Because I guess space is gonna be, well, no, time is gonna be pretty important. I mean, I guess 1 millisecond is not that much, because generation is actually slower than that. Yeah, it's not something I'm gonna do every frame, except for the server, maybe? Oh, no, wrong one. No. This one. Boom. So. Okay. Let's build again. But yeah, we have 304. Well, I guess it became like even lower. I guess it's like not very precise, right? That's why normally you have to run this multiple times and have like an average. But yeah, it seems to be good. So voxel, well, NV voxels. This, and we have this amount of bytes. So we have like what, 100 type of blocks, and we have less than 1 byte for every voxel. That's pretty good. That's pretty good. We should also, you know, optimize it like depending on whether we have multiple blocks that follow each other, basically. But yeah, that's pretty good. Can I get the amount of bytes per... No, I can't. Well, that's fine. I wanted to know the amount of bits per voxel. But that's fine. Because I guess... Wait. Let's have this again. Default size. Let's have something like 50, 50, 50. Because this is what we want, really, right? NV cubes. I can have a bit more. Like this, right? I just prompted a save/load function for my game. Wish me luck. Good luck. Yeah, I'm trying to... I mean, I've tried to optimize this at the bit level. And I'm not sure... Well, this is not supposed to be the best optimization I can do. The best optimization I can do is like the repetition. But it should be fairly simple to do. So well, I wanted to try this one first. So we have that, and then we have the min and the max. Let's try this. 49, 49, 49. Let's say this is 0, 0, 0. And I want to check with this amount of blocks how much this is optimizing. Maybe not that much. Maybe not that much, really. But it's gonna at some point. Especially if like all the blocks are different. And I want to optimize this because compared to Minecraft, I'm planning to have like dynamic blocks. Okay, let's try this. Oof, this is pretty slow now. Yeah, this is like pretty random. I can't really believe the time that's displayed here. NV voxels. This, and bytes, this. So it's still, I mean, still a lot. It's still a lot. But we basically save when we have less than 1 byte per voxel, which is pretty nice. And we have, so this is byte, kilobyte. So it's 100 kilobytes. It's pretty big. It's really big for a chunk. 100 kilobytes. Like you do times 10 and you have 1 megabyte, right? So yeah, we do have to optimize this a little bit more. But it's not that bad. Minecraft chunk size, well, memory size. What? What? 150k? Oh no, when compressed. Yeah, never mind. Yeah, that's, 4 kilobytes will be the goal. Ooh. Uniform named and compressed using zip. I want this. So I need this. I need the zip. Each chunk belongs to one and a region. The file starts with a fixed size table indicating the location and length of data of each chunk in the region within the file. What? Everything in the chunk is in the chunk's NVT tag. Chunks are divided into chunk sections to save space. Empty chunk sections are not included. I'm also currently optimizing soy chunks in my frying pan. Soy chunks. Yum. Block IDs were stored in a byte array. 1 byte per block. Yeah. Oh! Yeah, they had more than 256 blocks. Yep. So now... yeah. That's basically what I had, right? Or what I have. I actually have less than 1 byte per block. For some reason. Yeah, how is it possible? Wait. Oh yeah, because I haven't reached 256 yet. Yeah, so now each chunk has a block palette. A list of the different block states. Wait, that's exactly what... Wait, that's exactly what I have! A list of the different block states that is in the chunk, which includes the name of the block and the block's properties. Wait, that's what I have! Except the orientation, I guess. Oh! Wait. In the block array... Oh, that's why... Okay, I understand why a certain block was happening. In the block array, which is a sequence of integer indices into the palette. Yeah, that's what I have. I have the same. The size of the indices depends on the size of the palette. To save space, that's exactly what I have. The palette of 16 blocks only needs to be indexed by 4 bits. Whereas a palette of 512 blocks must be indexed by 9 bits. That's exactly what I have. It's the same, we got the same idea. Oh no. Well, I mean, I guess that means I'm in the right direction, right? Representation in memory, I'm pretty sure entities and tile entities are just like ordinary objects. Wait, that doesn't justify the size. Wait, does that just mean gzip and zlib are that good? No, they're not. No. It was 6 years ago. I think chunks typically take up this amount of bytes. They require to be a multiple of this, the size of a sector on your hard drives, with any necessary padding, plus each region file has this amount of byte header. Wait. Oh. Well, that's bad. I mean, I'm just gonna go. I mean, I don't. Load type, level, nana. Well. Chunk file format. So NBT. Sections, compounds, block states, palette. Set of different block states used in this particular section. And the data. Pointing to the palette. Yeah, I have the same. Started an array of longs. Wait, what? All indices are the same length. Oh. The indices are not packed across multiple elements of the array. Okay. If there is no more space, starts instead as if wait, okay. Biomes. Well, other things. Yeah, there's like a lot of stuff. Zombie. Oh. Village. As a zombie village? Oh, there are zombie villages? Block format. YZX. For compression purposes. Understandable. Have a good day. Oh, in the NVIDIA format. Well, okay. Indices are ordered like in a book. When it's top to the north. Read from beneath. No. I mean, it does make kind of sense to start with Y. I was actually thinking about doing this too. The pseudocodes didn't know. Nibble 4. Tile tick format. NVIDIA file format. Minecart deprecated. Yeah, they added just a bunch of stuff. MCA. A header containing location. No. Location of stats. Timestamps. Yeah, okay. Good enough. Compress using. Oh, okay. Okay. But the modern versions use the local block state palette inside. Yeah. So my question is, how can it reduce the size that much? Is it well, is it? Or are there more compression techniques? I mean, there are more compression techniques. The secret lies in how this data is structured before it's even compressed. Yep. Palette base, block storage, biggest saver. Custom dictionary. Only the blocks present in that specific section. Yep, that's what I have. If your subsection contains only 3 things, then it's free. Only 3 states, so 2 bits per block. That's what I have. The file dynamically adjusts its bit depth. Yeah. Global palette shortcuts. A solid chunk of air. Minecraft optimizes even further. Zero block data array. Simply lists a single entry in the palette. Air. The game instantly infers the rest. Okay. Sparse, yeah, I mean, sparse representations, that's the biggest thing. Is it? Wait. Self-allocating memory for potential data of every single coordinate. Minecraft separates basic blocks from complex data. Intricate objects. Yeah, I mean, yeah. Empty space or simple blocks. Don't pay the data tax for features they don't use. Yeah. Component level compression. Deflate. Wraps each individual chunk payload in a standard compression envelope. Well, okay. Each chunk is independently compressed before being written. And the STD compression. Even better compression ratios and faster decompression speeds. Let me check this. GitHub. And real-time good. Allegedly, I have a save function now. Oh, nice. Nice. That was fast. It took me 2 or 3 streams. So yeah, how much does it save? Around how much does the STD save? Also, doesn't Minecraft store, well, optimize block types that are the same consecutively? Oof, oof. Oh yeah, that's a lot. So you basically get 10%. So that's at 10 kilobytes in my case. However, when comparing the STD directly to Minecraft's traditional compression algorithm, the actual file size savings on disk are more incremental, usually around. Oh yeah, compared to NBT. Yeah, never mind. Forget about that. Well, okay. It's speed. Ooh. The city is faster than ZLive. No more like spikes. Well, I mean, you can just put it on another thread. The CD allows developers to train custom dictionaries. Train? Oh. Oh, okay. Oh, yeah. I mean, I guess it's nice. No, it doesn't? Wait, it doesn't do that? However, it uses a clever structural trick that achieves a similar result. Why is the X array ordering? Wait, what? Why is it doing that? Moving horizontally shifts your data across the array. Yeah. If you have a flat desert floor, a layer of sand stretches out horizontally. Yeah. Well, yeah, I guess it's better in that sense. Vertical ordering inside the binary format of a chunk section. Minecraft arranges block data in YZX sequence. It reads straight up the Y-axis. It steps one block over this. Then finally X. Oh, I forgot, but... Oh! It's pretty slow, right? But I forgot that it's because I was in debug mode. It has the debug symbols. It's not even optimized. So we can have like a gain of 10x. Or like 100 maybe. I don't understand why it's working better. Identical blocks are almost always stacked vertically. I guess. Well, okay. We might have 10 to 15 blocks of solid stone. And by forcing the array format to read vertically, it intentionally groups identical blocks consecutively in the row. It groups, well, I mean, you want the amount here. Well, I'm not sure about that. I'm not sure about that. But I could optimize things pretty easily, I feel like, but another time, I suppose. Yeah, I mean, 100k is not good enough. This is not good enough. This is really bad. Is it? Wait. Because I guess I have like a lot of different types. But in the end, I shouldn't have that many types. Like, let's say we only have 30 types. What is it gonna be? I'm procrastinating finishing the stream. I'm procrastinating so bad. I'm procrastinating so bad. Run tests ready. So before it was 100k. And now we're gonna get down to link. Please link. Done. Okay. From 100 to 80k. It's not that much of a save, is it? Wait, do I have more blocks though? No. Yeah, it's not that much better. I feel like a lot of it is actually due to the strings. But anyways. Okay. That's gonna be it. I'm gonna finish. I just have to push out of this. I'm gonna do that next time maybe. Oh. Uh-oh. I mean, thanks again, everyone. That's gonna be it. We're just gonna raid I Heard Funny Boys, because she raided me last time and it was pretty nice. I forgot to... Well, yeah, it was pretty good. I appreciate it a lot. So let's do that, and I mean, I'm gonna push and that's gonna be it, right? So... Wait, you need tests? Good luck. Oh, that's a unit test. Oh, right, I have Oh no! I should have that with my engine. Oh no, that's bad. Well. Well, that's bad. Is it? I want to move this to... I mean, this is just the beginning, right? So yeah, I want to move this to my engine module. So, unit tests. Let me check what I have. But, yeah, I don't have anything much. Anyways, thanks for watching, everyone. Bye-bye. See you next time. Boo.